Good morning, good evening, good afternoon, everyone, wherever you are. Welcome. Thank you for joining us today. Today we are streaming to all the platforms. Twitch, OpenShift is everywhere. Twitch, YouTube, Facebook Live, you name it, we're there. Today I'm joined by two of my favorite coworkers. These are two of my teammates on my actual team, Christian Hernandez and Jaafar Chraibi. I finally learned how to say your name, Jaafar. I'll let you all introduce yourselves. Let's do it in alphabetical order since you just took a drink, Christian.
Yes.
Yeah, so Christian is on the West Coast. I'm on the East Coast. And Jaafar, well, Detroit, and Jaafar is in Paris, right?
Yeah, he's in France. So we're spread around the globe here.
We have half the globe covered.
Yeah.
We've all got coffee, though.
We all got coffee. Apparently, everyone drinks coffee. So my name is Christian Hernandez. Like Chris Short said, I'm on the cloud platforms BU. We're on the same team here. And so is Jaafar. Actually, I'll let Jaafar introduce himself, but this is Jaafar's first time on the Twitch channel. Right. Although he's on our team, but he's been busy. So Jaafar, I'll go ahead and let you introduce yourself.
Yeah, thanks. Thank you very much. Thanks all for joining us. So yeah, indeed, it's I'm finally happy to be able to join the Twitch sessions. I've seen many great stuff that has been done by my teammates. And so I'm Jaafar, and I used to be an SA for OpenShift for about 4 years. And at some point, I decided to go to the other side and see how the sausage is made, actually. So I decided to join the OpenShift BU. And as part of the team, I work as a tech marketing manager for OpenShift. And I'm just happy to be able to provide enablement stuff and things like that.
So just to point out, Jaafar and I think joined the team a little pretty close to each other. I feel right? We had our first team meeting together last December, right? So Jaafar and I met in December. It's been just absolutely wonderful working with you, Jaafar. So thank you for joining our team.
Yeah,
you've done some really tremendous work so far. So
so far so good. So he's too humble to mention, but Jaafar actually wrote an article for a magazine in French, right? So he wrote it in French. So if you could speak, so I don't know any Canadians that are on the Twitch the Twitch chat right now, but they can maybe read it over here. But Jaafar, talk a little bit about your the magazine article you wrote about.
Yeah. So that's one of the things that we've been busy with. So I wrote it with two of my colleagues. So Sébastien Blanc and Laurent Boudou. Awesome job. Thank you guys for your work on that. So we had a very good opportunity with one of the most read French developers magazine. It's called Programmer, and they offered to have an edition speaking with a good part of the edition dedicated to OpenShift. So we wrote a set of articles. We built an application to go through from zero to hero on OpenShift, like how you build an application using source to image, how you make that, you deploy that through different environments with the pipelines that we provide, how you integrate serverless, how you do monitoring of your application workloads. So it covers a lot of stuff. We have also provided sample codes, so the readers can just go to the GitHub repo and start playing with the sample app. And actually, you can just try it on try.openshift.com or learn.openshift.com. If you go to the OpenShift playground, and you're going to be able to go through exercises.
So not only
that was the goal for us.
Yeah, so you have the code there. So, but you can actually go to learn.openshift.com playground and actually try the code out. So you can have your magazine
from the magazine. So you can have
so that's pretty cool.
So when do I get a copy? Is the question, right?
Next time we have a team meeting, you need to bring copies for everyone, so that way we have.
Yeah, sure. We're actually putting few hundred copies for our French customers.
Oh,
and
sweet.
I'm gonna try to steal some of them for you.
That'd be great. I apologize for the dog barking in the background. My family just got home from the grocery store, so if you hear it, sorry. Her name is Sunny. She's a great dog.
Oh, okay.
So Jaafar, did you mention the publication? What was the publication again? The
yeah, so I'm gonna send the links. So it's something that can be downloaded from. You can get the magazine, obviously, for French-speaking viewers.
Yeah.
But I'll post a link to the GitHub repo too, so you can.
Yeah, thank you.
Maybe try the samples and go through it. Although we are still writing the English documentation.
Okay.
English version. Okay. So you are going to do a translation?
Nice. Yes, I'm going to do it. I think next week I'll start translating all the instructions to English. So yeah.
You're a beast, man. You're a freaking beast.
That's crazy. All right. Nice.
You're awesome, dude.
Available
wow.
there.
So like, again, I'm very happy to have Jaafar on the stream today, if you can't tell, right? Like, I'm super happy that he's finally here.
Yeah, he's finally here.
He's finally
he was
here.
busy writing his article, so
yeah, he's been busy being a super famous French magazine writer. Yeah,
that's right. That's
so
right.
well, let's get started down the actual reason we're all here today, folks. So we're talking about infrastructure nodes, right, Christian?
Yeah. So we're talking about infrastructure nodes and what they are. What is this whole thing of infrastructure nodes? And this is actually a concept that Red Hat brought up in the 3.x days, right, in version 3, where the idea of separating your workloads, right, separating your application workloads from the core platform workloads, right? So things like when you're running Kubernetes, OpenShift, you have things like the control plane with all its components. But there's also supporting, right? There's a supporting cast there, right? So there's this supporting cast that not a lot of people talk about. That things that are running that make OpenShift, right? So you have your workload, you have your control plane, and then you have this other workload that kind of just doesn't really fit in between those two workloads, right? So Red Hat came up with something called the infrastructure nodes, right? Infrastructure components that are important to run OpenShift, but they're not necessarily workloads, right? So in I think Jaafar, you have kind of like the differences, right? Like, because we introduced this in version 3, but we're gonna you also can do it in 4. So I'll let Jaafar kind of talk about that a little bit more.
Yeah, sure. So for the people who don't have an OpenShift background, obviously OpenShift is a Kubernetes platform, but it's just more than that. It's not only the orchestrator, it has a lot of components that we provide out of the box, amongst which things like the router, HA proxy router that allows you to get traffic into the platform, or the integrated monitoring stack, or integrated login stack based on EFK, Elasticsearch, Fluentd, and Kibana. But we also have an integrated container registry that comes out of the box with the platform. So all of these components are running as containers on the platform itself. And the question is, so there are two aspects to these. The first one is from a technical standpoint. On Kubernetes, you don't have this notion of infra node. It's just, you have masters and workers. But at Red Hat, we decided to provide a way to isolate those technical components like the registry, the router, and the login stack on some set of separate nodes to relieve the worker nodes that will be running your applications. So that's the first aspect of it. It's from a resource management standpoint to not have overlap of technical components that come with OpenShift with your actual applications. And the second aspect to that is from a subscriptions standpoint, from a money standpoint. We don't make you pay for technical components, and that's what the infra nodes are for too.
Right. So I like to think of the infra nodes as like an extension of the backplane, maybe, right? Yeah. Like it's a kind of a not perfect, like it's not synonymous or whatever you want to call it, but it definitely increases the capability of your cluster itself, right?
Yes, correct. So those infra nodes, same as for the control planes, they are not counted as what you pay for when you buy OpenShift. So you only pay for your nodes, worker nodes that are running your applications. So that was what we introduced with OpenShift 3. And with OpenShift 4, if you go to the standard installation, it's not something. So we still provide this notion of we don't want you to pay for technical components, only for your application workloads. But with OpenShift 4, you have to sort of decide after installation that you want to migrate those components to some dedicated nodes. And I think that's what Christian is going to walk us through. So I have some magic going on here to make him give us his tips and tricks to make it work. And there's also, I think we're going to have some tips about how to make it pre-install, actually, how to configure manifests to have those nodes that are dedicated for infra components to be generated pre-install.
Yes.
Or at install.
At install. It's great to have your cluster and then realize okay, I need to add a couple of infra nodes. That's a totally understandable scenario, right? But it's totally different when you're I know I need infra nodes to begin with. Yeah. So let's build them at install.
Exactly.
Yeah, correct. And it's and as Jaafar mentioned, there's a pricing component, right? So there's a component to where if you're not running infra nodes, you're essentially taking up the resources that would have gone to your applications.
Not running your
nodes. You're an echo.
Sorry.
Who opened Switch?
Okay. There's an echo. No. All right. Good. All right. Maybe I check my headphones out. No. Yeah, inside joke. Sorry, guys. So
the story behind it, I realized I wasn't on the Twitch, so I just opened it right now.
Oh, so that way you can look at the chat.
Oh,
gotcha.
Yeah.
Yeah. So as I was saying, you're utilizing what would be for your workload for infrastructure components, and so it's best to move those off, especially since they're included right in the subscription. So you have a subscription, you just add more compute power, but then you won't take a hit against your subscription here. So and so the so someone just asked a question, but I literally just answered it as I looked at it.
So the stream, keep in mind the stream in the chat, we are talking probably about 30 seconds ahead of the chat. So it's pretty fun to answer questions in flight.
So I'm gonna share my screen here. Let me see which one. I think it's this one.
You can do it. I believe
I can do it. Do you see?
It's look,
I have a new don't forget my headphones. I have a new welcome page here. In case you guys didn't know.
Thank you.
Right? If you go to OpenShift.com/streaming, you'll see. I'm gonna give you a little bump here. Chris.
I appreciate you.
Yeah. See here. It's our one stop to be able to get to our Twitch channel, which is this channel, but we also stream to YouTube and Facebook Live. If you want to see upcoming events, there's a big red button that says see calendar. And yes, you can go to OpenShift.tv and it rewrites it to this page. So
and the calendar is a Google Calendar, so you can add it to your own, subscribe to it, embed it in your website, whatever you want to do.
So that's so someone asked, I'll ask the question, and I won't answer it right away because I'm going to answer it while I'm doing this here. So other than labeling for scheduling purposes, what special configuration might infra nodes have?
Great question.
So I'll get to that specific. I'll answer that specifically because I'm actually going to do that here. So let me go. Yes. So I have here my Twitch directory. So by the way, I have a Twitch directory that has all kinds of stuff that I just keep the stuff that I mess on. But I do have an OpenShift directory here. So what I'm going to be going through is I'm going to be creating infra nodes, one at install. And then I already have a cluster up here. I have it in US East 1, I think. No, US West 2.
Thank you.
Yeah. So I already have an up and running cluster. So if someone already has a cluster up and they want to create infra nodes after the fact, I'll show you how to do that as well. And then we'll move some of the workloads over here. So
a challenge.
So yeah, exactly. So yeah, so to get it at install, let me go to US East 1. I have, by the way, my, the standard, is it AWS creds? What's it called?
AWS credentials, or is it dot credentials now?
Credentials, you're right. So yeah, so I already have my AWS keys and all that set up. So I assume, since this is an Infra nodes, I assume you know something about OpenShift, right? This is a little bit more mid-range level here. So if so the first thing I'd like to do is I'd like to do OpenShift install, create, install config, right? And this will actually generate, if you actually invoke the help, right? You can do OpenShift create cluster, create initial configs, install configs. So you can actually do these. You don't have to do the complete automation. You can just do these in the individual steps, right? So I'm going to do create install config, right? And this will go through the standard wizard here, AWS, and where am I? East 1. So let's do that. Let's pick a base domain. Yeah, I have a ton apparently.
You?
Yeah, okay, yeah, exactly.
The DNS master has a lot of domains.
I have a ton of domains. I may not be squatting on a few, but yeah.
Same here.
if you just start picking Greek words and just pick a Greek word.io, eventually someone's gonna come up with that name. Or at least that's the hope, right? And then they'll pay me,
$25 for it.
Yeah, $25 for it. Yeah, whatever it is, right? And then the pull secret, I actually have a command that shows me my pull secret. Those of you who have you've probably seen my pull secret enough to probably memorize it. So what this does is it generates an install config, right? So I did.
I'm trying to hack you right now. So
okay, yeah.
It's just me.
Yeah. I mean, you can sign up for a free account. So as we've always said, just sign up for a free account.
Try.openshift.com or openshift.com/try.
Yeah.
And you can kick the tires and light the fires on your own cluster.
So the reason why I created an install config is because I need to edit this. Why? Because the workers come too small.
Okay.
Right, and I need to add, what was this called again? This is, I think size or,
I'm looking.
OpenShift, or I think it's, let's look at the doc. Let's do it
to the docs.
Let's do a docs.openshift.com. Let's do an Eric Jacobs.
We read the docs here, folks. Yeah.
We love reading the docs here. So container platform 4.4. Installing AWS, installing with cluster customizations. So here, I want type. So it's platform, AWS, and type. Okay.
Nice.
And then type, I want, what do I want here for the type? I want M4 .2XL.
Right? 2XL, yeah.
Something big, right? M4 2 extra large.
That's
and big. That's pretty big, right? And then masters should be fine the way they are, because there's not that much running on the masters.
Yeah, I think you can leave the masters.
Masters should be okay. All right. Usually I do for like, but I got in trouble before for creating big clusters. So on this account, go. Yeah, you had a question, someone?
Well, I was just going to say, like, is that name master arbitrary, or is that something that has to be defined as master?
No, it has to be defined, right? So,
okay. So we haven't worked that quite out of the system yet.
Correct. Yes. We have not quite yet. Yeah. There's this. I'll explain later about hard coding things in code. It still happens all the way up to enterprise software. Anyway, but yeah. So this is so really this is. I did nothing special. I did create install config, and the only thing I edited was I'm asking for bigger workers. So I do AWS, and you get that in the doc here. So in the doc here, it tells you all the customizations you can do in your install config. So once I do that, OpenShift install create, right? And the next step would be to manifests, right?
Yes.
So
all the manifests.
Install create manifests. So what this does is, as the name implies, it creates all the manifests for the installation of OpenShift, right? So for example, there's the specific OpenShift components, right? So if I, let me actually, right, there's things like, things I won't cat, like my cloud credentials. But other things like, you know, the install manifest, right? So this is the actual install-config YAML file here. Various secrets. There's also actual manifests, things like my cluster config, my DNS config, things like network configuration. So if you ever need to make customizations so first and foremost, when you're making customizations, always make them in the install-config.yaml file. Always make them there. Yeah. And so, and then if you can't make them there, they make them in the manifests. And if you can't make them in the manifest, you have to, that's like a day 2 activity, right? After the cluster installed, then you get to modify all that after install.
Yeah, so, and just another tip, if you tried generating the install manifest from the file, is to keep in mind that it's going to be deleted if you run the installer.
So yeah, notice it's not there anymore. Yeah.
Yeah, so. Always keep a copy of it somewhere, or use -- directory to actually generate stuff in a different folder and not override the current.
Yeah, the current state of where you're in. Exactly.
Yeah, so Craiger just asked, you know, for OpenShift 4, he was, you know, planning to do smaller clusters. So he's not really using a lot of the logging and everything else. So he doesn't really need, you know, infrastructure nodes. And that's totally fine, right? Like small clusters don't need infra nodes, right? Like that's totally cool.
Yeah. And if you're using smaller clusters and not all the bells and whistles that OpenShift gives you, you can use OKE, right? So OpenShift Kubernetes Engine.
OpenShift Kubernetes Engine, yeah.
So you can use that, meaning like, oh, I don't want
that link.
Yeah, so I don't want, you know, all the, you know, we're going to use this basically as a CAS, right? So a container as a service. We're not really going to be using all, you know, all the different functionalities. So OKE is perfect for that. So and yeah, that's perfectly fine.
Totally.
And so here we are. So I have here these manifests. I'm going to go into
the question about the
yes.
Can it be 3 masters with scheduling enabled? So you could do that, but then you would have to beef up your master's config.
Yeah.
To cope with the new workloads that you're going to be running on it. But you could.
Yeah, you could, and but it's you have to know it's tech preview for version 4. But yes, you can have what do you call it? Compact clusters. I don't know, 3 all-in-ones. I don't know what people call it, but yeah.
So I don't know if the question was to have only a 3.
Oh, got you.
Or keeping the workers as they come out of the box and making the masters schedulable to deploy stuff.
Yes, you can. However, there's a subscription component to that. That means that you have to start paying for however many cores are on the masters.
Correct.
So.
So
there you go. So there's that. But I mean, you can. Yeah. So it's just caveats, right? Just buyer beware. Like, you know, as long as you know that and you want to do that, that's fine.
And so I think that at some point you're gonna tell us how to make sure that nothing else runs.
Yes. Yeah.
On the infra nodes.
Correct. Yeah.
Okay.
So one of the things. So here I am in the OpenShift directory, right? So like, let me go back up one, right? So I was here, and then I went into the OpenShift directory because I want to call out the machine sets, right? Oops, machine set. Okay. All right, so there's a machine set for the workers, right? And you notice here that there's 6. Why are there 6? When I asked for 3, right? I asked for 3 workers. Why are there 6 machine sets? So getting familiar with the concept of machine sets is kind of like the idea of a deployment, right? So you have a deployment, right, that handles replica sets that then deploys pods, right? Similar to the idea of that, we're taking that up to the infrastructure layer. We're taking that, we have a machine set that will deploy a machine that will then deploy a node, right? That will then become a node, right? So you can totally have a deployment with a scale of 0, right? You can have a deployment, it'll be there, it'll be scale of 0, right? So if I take a look at, if I grep replicas, machine set, you notice that there's a replica 1 here, 1 here, right? And 1 here. So that's 1, 2, 3, and all the other ones are 0, right? So what are these, right? So each one of those, since US East 1 has 6 availability zones, we'll have a machine set for each availability zone. Just some of them will be scaled to 0, right? So that's that idea. So if we actually take a look at one of these, let's take a look at one that has
you should be able to guess the AZ from the labels or the names that are in there.
Yeah, so if you go here, if I look at a machine set, right, this one is US East 1A, right? So that's that availability zone, right? So zone, US East 1, oops. Right, it'll say here a placement, availability zone 1A, region US East 1, right? So so you'll have a machine set essentially for each availability zone. So essentially what ends up happening, let me just LL this here, is that when OpenShift installs, when it'll actually do kind of like a cube apply of these manifests, and these are how the machines come up, right? And so in order to create infra nodes at install, you essentially just copy this and modify it for the infra node. And there's actually a doc for that. So if we go back to the documentation page and we go to machine management, and then there's a section here called creating infrastructure machine sets, right? And then here it'll give you an example for different clouds, right? Creating machine sets for different clouds. So depending on which cloud you are, whether you're on AWS, Azure, or GCP, you need to do something a little different, right? So since we're on AWS, we're going to follow this guy right here. So this here is an example of how to do it post-install, but this actually also applies for pre-install, right? So you can actually go here and start editing these. So let's actually create one. Let's go to worker machine set 0, and then we'll call it infra. Right. So now we have a file called infra. And let's edit this here. So this is gonna be very watching water boil, right? We're gonna go one by one, right? So first we need to change the label to match the infrastructure ID. Infrastructure ID should be the same, right? We're installing the same cluster. It's the same cluster, so it's the infrastructure ID. We're going to change the name, right? Infrastructure ID, role, and zone. Right here, the only thing we're going to change is worker. Sorry, we'll call this infra. All right, that's 2 down, 2 down. And then we're going to go to the labels and change, make sure the labels match. So infrastructure ID, infrastructure role, zone. So infrastructure ID stays the same. Zone stays the same, ID, but the role is infra. All right, that's 4 down. And then the labels for the actual node. So we're here, we'll change this to the infrastructure ID, which it already is. Role is infra. machine type is infra. And then here, cluster ID, infra US East 1A, right? We want to keep that as the same. Here we need to add something in the spec, right? So here's spec. This is where it gets interesting, right? So here we do, what is it here? Spec metadata labels. And the label here is, I'll just copy pasta here because I want to get this right.
I love some copy pasta in the morning.
Love some copy pasta in the morning. Here I want to change. Here I want to change this role to infra, right? So here is the first step into creating the infra node, right? All these things I did beforehand is just basically I'm just creating another machine set, but this is actually makes it an infra. Here is I want to do the node role Kubernetes IO infra. So this when you do your node selectors, right, for your pod placements on your on the infrastructure components, it will attract it to these particular nodes, right? It'll attract it to these nodes. But there's nothing that prevents other workloads from landing on the infrastructure nodes, right? So so how do we make this a true infrastructure node? Like how do we isolate this node so that way it only runs the infrastructure workloads and not application workloads, right? Remember, as we said before, as soon as a workload comes in, you have to pay for that infrastructure. The same as with the masters. As soon as workloads come in, we no longer consider an infra node, and you have to pay for those cores, right?
Yeah.
So how do we?
Yeah, when you say workload, like the customer's applications.
Yeah, your applications, your your cool stuff store, right? Yeah. Application. So here, let me make this a visual so that way you know I know where I am. So what I'm alluding to here is things called taints and tolerations, right?
Yeah.
So what you want to do is you want to add a taint to your infrastructure node. And then you need to also not only add the node selectors for your workloads, but you also need to add the tolerations. So let's talk a little bit about taints and tolerations, right? So let's Google that. Taints and tolerations is the first one here. Yeah, here we go. So you taint a node kind of really easy, right? You do a key value and you do a colon and the effect. Like what's the, let me make this a little bigger so you guys can see.
Yes, please. Thank you. Sorry.
Yeah, no, I'll make this a little, I saw you squinting and I'm like, oh, maybe this doesn't look as big as it does on my screen here.
Yeah, no, I'm squinting because the Twitch chat is tiny. And
yeah.
I always got to make the interface bigger.
So yeah. How do you make this bigger? Because I'm actually struggling here too. Oh wait, I can make it that bigger.
Command plus on a Mac, Control plus on a everything else.
It's Command Shift plus. There we go. Or Control. Yeah, you're right. Yeah. So a taint. This is essentially you do a key equals value and then whatever the effect is, right? And to remove a taint, you just do that, right? So, and then when you do a toleration on your workload, you need to add that toleration. So for example, here. I want to tolerate the taint, meaning I'm able to run on this workload. So key value, that makes sense, right? So, but what does the effect do? So let's take a little bit time to read what the effect does here. There is.
You can do it, I believe.
Is it on this? You know what? Not for naught, but I think I like art documents a little better when it comes to taints and tolerations. In this specific case.
Yes.
Let's see here. Controlling pod. Okay, there we go. Let me close this guy.
So what is it that you're looking for, Christian?
There we go.
Yeah.
So here, I want to talk about the effect, right? So like we have key value makes sense, but what does the effect does, right? So there's three effects. Mm-hmm. So the first one is no schedule. So I'm literally reading from the page here. It says new pods that do not match the taint are not scheduled on the node. Existing pods on the node remain. So when there's a taint, when you taint the node with no schedule, that means current workloads still run there, but new workloads won't get scheduled on the node. And then there's preferred no scheduled, right? New pods that do not match the taint might be scheduled onto that node, but the schedule tries to not, right? So this is kind of like a maybe, right? This is used mainly as like I want to keep I want you to avoid these nodes, but like if I'm reaching critical mass, go ahead and use those, right? So the schedule tries not to unless it has to.
So basically they get a lower priority on the scheduling algorithm.
Correct. Yeah. So they basically bump them down on the priority list. And then there's no execute, right? So this is like the hammer. I'm dropping the hammer on you. New pods. So this new pods obviously don't get scheduled on this nodes, but existing pods that don't have a match will get evicted. So not only new workloads won't get in there, if there are workloads that don't match that don't tolerate the taint, they'll get kicked out. So that's kind of a kind of heavy-handed, right? So but in general, this is
it's like draining the node out
it's essentially it's essentially draining the node, right? So what we need to do here, not only do we need to add the label, we also need to add a taint, right? And the taint goes, I believe, the same level as metadata. Okay, so let me go back here. So so I'm here in the so it's metadata. Oops. If it's the same level, I want to add taints, right? So it's an array just like everything else. I want the effect. So I want to use no schedule, right? Because I don't want to be that aggressive, but I want to be aggressive. So what does no schedule do again? Let's go back to the doc.
So do you want no schedule or no execute?
No schedule. So new pods that do not match the taint are not scheduled into the node. Existing pods remain on the node, right? So that way, that in case
if you have daemon sets and stuff like that.
Yeah, and also if I have a workload on there that if I have a workload that, let's just say, it's kind of like a sensitive workload, right? And I want to control when I empty out that node, right? Maybe I want to do it during downtime or whatever, right? I want to have control of when those workloads move. So I want to do no schedule, and then I want to choose the key of node function. These are arbitrary, right? You can pick whatever you want. Node function, and then the value of infra, right? So I want to the key is node function equals infra, and then the effect or colon is no schedule. So that those are so again, I forgot who asked. Let me go back to the chat. Washari, W Shari.
Waleed. Yeah. He's one of our longtime friends.
Yeah. So one of our the guy we owe the shirt to. So,
like seriously, every week it's part of it's a topic. It's a bullet point. Right. It's like how can we get anything? No. Okay. Yeah. Still looking. All right. Yeah. We're working on it.
We're working on it. Yeah. We're trying. And so someone says perfect use case. Start the pod only when there's traffic on the chat. So kill it all. So you need to add the taints and the label selector. So now when this node comes up, it'll be properly labeled and it'll have a taint. So then you can start moving workloads onto the node. So what's next here? So hopefully that made sense. That hopefully I had a lot of copy, so I'm prone to go fast. So so the provider spec. The next is the AMI ID. Well, since since I use the installer, let me right there. Since I use the installer to generate this, I don't have to change it. So, and the next one is the ID, infrastructure ID worker profile. So here, infrastructure ID worker profile, that's fine. We leave that alone. We don't change that. Instance type, we'll leave it at the big mama 2000 here. Availability zone, US East 1A, East 1, 1A, E1. Infrastructure ID worker security group. We still want this in the security group, so we don't change that. And then the subnet filter, leave that as a private. Infrastructure ID, same as infrastructure ID. And then tags, infrastructure ID, right? This is in worker. So here we go. We have our first infra node. So that's for node 1. And then you can go and create this 2 more times, right? Because I want one for each availability zone, but it'll just be easier if I just copy this one I have to give this a number 1, right? Instead of US East 1A, US East 1B, right? Everything else is the same, right? So it's essentially, we don't need to change much here, except the fact that this will be in 1B. And then we'll do the same and make this 2, and this is 2, and then US East or West, I'm not sure. 1A.
West is the best.
Yeah. US East 1C, right? C. So in the end, right, in the manifest here, you'll have 3. Right, so you have 3 machine set, 3 infra nodes machine sets. If I do infra and then worker, right, I'll have a machine set for the workers and for the infra nodes. So straightforward, pretty easy. And so now what we do is, so there's this little, hopefully someone in engineering is watching this. I found the bug, right? So, yes.
Really?
We know what's funny that when Jaafar said, I want to see how the sausage is made when you join this team, you literally, like when you get like the preview builds and like you get a lot of ugly sausage making. But I did find a bug. So in this so one of the workers, one of the workloads that are eligible to be on the infra node is the ingress controller, right? So the ingress controller, you want to move that to the infra node, and in order to do that, you need to add not only the node placement but also the tolerations, right? So here we have cluster ingress config. So this is actually the CR, right? So this is the operand for the ingress operator. Mm-hmm. And you can actually add some like node placement. Did I spell that right? Placement. Okay. It's early for me. Node selector. And then in the node selector, it's match, right? Match labels. This is like node role, like someone watching you type, right? Like you make like, you're like the world's worst typer when someone watching it. Netease.io infra equals, right? So this will actually try to place it on the infra nodes. Mm-hmm. But then it doesn't have a toleration, so it'll just basically you'll get an error, right? It'll try to place it on a node, because it can't on the infra node, because since I put a label selector, it won't match the workers. But then it doesn't have a toleration, so I need to actually put a toleration here. Tolerations, and for the tolerations, is you essentially put the same config. What was the config here? OpenShift 99.990 OpenShift cluster API infra machines. Oops. Wait, someone said you misspelled node labels. Did I?
Did you really?
Oh,
that
man.
Wouldn't surprise me.
Yeah, I've been known to make spelling mistakes, like terrible spelling mistakes.
Same here, right? Like,
yeah.
The exact same stuff.
Yeah, so let me.
The E and the I are swapped. Well, that's even a common mistake.
Yes, right.
Wow. When English strikes.
Yeah, when English strikes. That's right. So the English. Let me see here. Node. Oh, I did. There we go.
Wow, good catch, Andrew.
I know. Andrew, can you look at this config and make sure?
Yeah. Can you be our linter?
Yeah, exactly. Yeah, please lint this for me.
Dry run this for me. In your head.
Yeah, in your head, dry run it. So no, and then the effect is set AI. I think it is. There we go. Key is node function. And then value equals infra, right? So this is, there we go. So the node placement here, this is kind of, for whatever reason, it's upside down for me. Oops.
Wait, what?
Let's see, 1, 2, 3, 4, or DD, P. All right, now for some reason, like in my head, that was upside down. Now it looks fine for me. Do you ever see, do you have ever seen someone else's YAML and it looks upside down to you? Because like it's not like it's structured incorrectly. It's just they would put it in different places that you would put it in.
Oh yeah. Like the blocks are in different spots.
Yeah, absolutely. The blocks are in different spots. Yeah. And then I look at it. I look at it and I go, I think your YAML looks upside down to me. I mean, it's correct, but it looks upside down.
I think there's a plugin that Red Hat ships for validating YAML files for VS Code.
Oh. We do. If you were in VS Code right now, you'd probably have a lot of help.
Okay.
Plus we just had a show earlier this week about the OpenShift connector and how awesome it was. Like, I mean, I'm not going to say that like I'm totally abandoning the terminal, but like that thing is pretty dope.
Yeah. So do use it a lot to know where I'm at in the YAML.
The tree, just having that connection there in case I want to go dry run it or test or something.
Yeah. So by the way, so the little side here. Let's see, GitHub. I actually have a plugin called GoVim.
Yeah.
Or Vimgo.
Vimgo. Yeah.
Vimgo, and it essentially it's like an IDE.
Yeah. No, I know the developer for that.
Well, if you know, tell him thank you, because this is like
no, I tell him thank you for frequently.
Yeah, so like if you're doing Go, and you love Vim, that's like the best thing. Anyways,
it's the perfect combo. Yeah, literally.
Yeah, it's essentially the perfect combo. So yeah. So
I'm trying to remember his name. I think his name is Ari. So I forget. I will look it up though.
Yeah, I'm better with faces anyway.
Same.
So like if this was running on, like if you were like to load this on a running OpenShift cluster, it would work, right?
Mm-hmm.
For whatever reason, and we can test this right now, and maybe I did something wrong earlier, but for whatever reason this doesn't work on install. Don't know why. I don't know if they're not doing a kube apply-f because that would work. I don't know if they're actually like looking at if they're like JQing it, right? Or if they're like, if they're marshalling in the JSON and then doing it manually, who knows? But maybe I'm wrong. So last time I did this, it didn't work. So, but we'll show you how to move the workloads after. So So yeah, so that's the one bug. But you can actually, in theory, right? Let's step back and just theory. You can actually have the workloads land on there on install as well. So that's the nirvana, right? You want to get infra nodes with all the infrastructure components already over there, all on install. So, so yeah. So here, now that I have my my manifests in place, I can do OpenShift install create cluster, and this will actually go off and create the cluster for me. So we'll sit here and watch this until it's done. No, I'm just kidding. So I actually right, wouldn't that be a fun twitch? Well, watch the install go. So I actually like I said,
you just before, have that on as the background image, right? Like just a screenshot of the install.
Yeah, the install. just have that, right? So I actually already have a cluster built for this here. So let's cat the OpenShift install log file. Let's run this kube export.
There we go.
Is that it? There we go. OC get nodes, right? So I already have a cluster here. This cluster is actually sitting on US West 2,
Sweet.
Right? And I have 3 masters. I have the control plane 3 masters, and I have 3 workers, right? All in, so ABC.
Nice.
Right? Standard, right? So here, if you do OC get machine set, right, it'll show you that, again, remember when I made that analogy of the deployment has a scale, right? You can have a deployment of a scale of 0. This is the same idea, right? This machine set has a scale of 0, right? So that's why this worker isn't up in D. So you can actually do a scale of that machine set, and then all of a sudden your workload is you have another worker. So same idea, right? Let's go back to the doc. The doc here says you've essentially followed the same doc, right, to create a machine set for you, right? So instead of having, so since you already see me do that, right? I don't want you to like watch me over and over again.
Mm-hmm.
So let's just do OC get. I actually wrote a script that creates the machine sets for me. So let's go over to my infra nodes, and then MK machine set.
Ooh, fancy.
Yeah, I created a script that does it for me. So I'll show you some of the sausage making. So it doesn't. So, but by the way, like no one has. Have you ever seen like someone do a live demonstration? They literally have notes off to the side. There's no way people memorize this stuff.
No.
Yeah. Not even
Jafar.
Not even Jafar is that is that awesome.
I have a very low memory.
Yeah. So it's I write down.
Like I have notes for this show, right?
Yeah, exactly.
I have notes for producing. I have notes for everything.
So I want to get the machine.
Just for info, so we did run a couple of workshops with Eric Jacobs.
Yeah.
On the definition streams, talking about Kubernetes operations. And one of the topics that we addressed was how to do that on an existing cluster. So we will I'll send you a link also to the GitHub repo that has those instructions to be able to
wonderful
digest all that Christian.
Yeah, just drop it in chat.
Yeah, just drop it in chat, man.
Yeah,
share
all the resources. Share the wealth.
Sharing is
caring.
The knowledge. So my script, essentially what I do is I do a environment substitute of certain things, right? So here I need to add, maybe I'll share the script. I don't know.
You should, if you're writing the script, you should open source the script. We work at Red Hat, you know.
That's right. Maybe I'll put it up. Maybe I'll put it up on my helper node repo. I'll add it as part of as a helper node script. Yeah.
There you go.
So cluster ID. My cluster ID is where's my cluster ID? My cluster ID is West, and then this UUID thing here. So I'll do that. And then US West 2. I think that's where I'm at.
I hope so.
Oh, okay, that's where yeah. So that's where I tested it. And then the zones is A, B, C, and then the AMI, that's important. So let me change. Oops. Let me change. What is wrong with my? Oh, my fingers are in the wrong place. Okay.
Whoops.
Yeah, you ever start typing and you're typing? I'm like, oh, my fingers are not on home row.
Every day.
Yeah. So here's the AMI. So I need the AMI ID. Again, I'm not doing anything special after the fact, right? So like the same steps you do to install Infra nodes on pre-install is the same way as do post-install. I'm just using a script to speed it up a little bit. And then I have the template step here. Oh, by the way, I think I see Andrew on, and also maybe Langdon.
Langdon had to run real quick.
Oh, okay. I was gonna say this. This section here is why I was asking you about the index in Bash, right? How to get the index number. Anyway, I know that there was on Slack we had this whole conversation about how I'm trying to do things in Bash that I shouldn't. Anyways, so yeah, so I just pick every zone and then I just create a machine set using environment substitute. Very handy. Right, I have a template file, then I just write out Infra nodes, right? So, and then I can just do MK. So here, manifest should be an mks.out, right? So let's look at those. Make sure they're fine and dandy, right? So here, same idea. Remember, just follow this doc, or use my script later when I put it up. I noticed you didn't use any of our suggestions.
Yeah, nice, Andrew. Good.
Yeah.
There is a question that says, when can we expect to see the installer handle the Infra nodes without modifying manifest like this? And it's
So there's other things. So like, let's take a look at here. Let's OpenShift for my as Jaafar says, keep a copy of your install-config file.
Mm-hmm.
So notice here, it'll say there's a section for compute. Oops, let me visualize this. There's a section for compute there, and then there's a section for control plane. The idea being that eventually there's going to be a section for infra, right? So there's going to be like infra, right, like that, and then infra, hyper threading.
Yeah, you would
whatever,
exact same specs. Just say I want these infra size nodes. Just have that one install config. That's in the works.
That's the idea. So that's the idea is that that'll eventually come in. There's no what do you call roadmap for it yet, right? Like, so I can't tell you if it's coming next year.
We can't say definitively it's going to be here on this date. I mean, it's software.
Like it could be there next release, or it could be 10 years from now. Who knows? It could be OpenShift 5.
It's not 10 years from now.
It could be OpenShift 6 when it comes. Who knows? But
I hope not. No.
But anyway, that's the idea. Eventually, yes, they have thought of that. But there's like there's other things they want to get to first. But it is something they want to do for sure. So I have replicas 1. So all of this looks good to me. Nothing's coming out at least for me. That makes this cool. So I have the infra nodes, and then going back here, I could do OC create -f of infra nodes, and then can I do this? 0 through 2. Does that work? Does anyone know if that works? Let's see.
Maybe
0, 1, 2. So we'll see. We'll see if that works. Unexpected error.
Okay. No, I don't think it's gonna work.
I think I could just give the directory. Just the directory.
You can just give it the dir.
Yeah. And so if I do OC get machine sets, there is 3 more machine sets, right? So it created these. If I do OC get machines, it's in the provisioning phase, right? So it is actually creating these. If I go here and I refresh this here, it's actually going to be starting. Yeah, so it's initializing 3 more. So here, notice they're labeled infra.
Yep.
and they're all running. So this could take like this could take like 5-ish minutes. We'll watch it. Here, let's see here. Someone says that you have a Red Hat watch, Chris?
It's an Apple Watch with a regular with like $6 Velcro band from so like when I show off things, it's like, oh,
it's like red. You can see my hand.
Yeah. So actually, the inspiration was I was on a call, I think, with Andy from the Accelerators team.
Oh, okay.
She has an Apple Watch with like a full case and a full strap that's all red, and I was like, whoa, that's cool. I don't want the full like the Apple Watch case, but the red wristband, dope.
Yeah. So Andrew's answering a question here. Let's see here.
Did you use MCO to adjust the configuration? I believe labels will eventually be removed.
Yes.
Yes.
So this is actually good to call out. This is good to start conversation. If you let's go back to OC80M taint. So if you taint a node here, so for example, OCM this taint here, if you taint the node but you don't have it in the machine set, when this machine goes away and comes back, it won't come back with the taint. So any similar to like if you label a pod but not the deployment, when that pod restarts, you won't have that label. Same idea, right? There's anything that you want on the eventual node, you have to move up now to the machine set, right? So the machine set will then label all its children, right? All the things that it. So same paradigm. So start thinking about nodes as the same way you think about pods, right? So you can. So you just think about the same paradigm, right? So you can spin up nodes for like temp workloads, I guess, if you want, but like all the ones, anything that you want permanent, you have to go up a layer now to the machine sets. So
and just as you rightfully pointed out, you can think about the machine set as being the deployment for the machines or for the nodes.
Yes.
Well, actually, machine sets, and the machines.
The machine.
Or maybe, I think it would be. It's actually maybe closer to the replica set than to the deployment.
Yeah, it's close. Yeah, it is.
I think upstream they are working on something.
Kind of like a replica set, but for machines or whatever, or deployment. Machine deployment, I think is what they call it.
Yeah, something at the level of the deployment for the machines.
Yeah.
On the machine API, on the machine SIG machine API.
Some Red Hatters had a Red Hat tattoo in his forum. I actually know him.
Yeah, I
actually know him. He actually was on the OpenShift team, OpenShift Online team, and now he's on the Ansible side. So it's kind of funny. You went from Ansible to OpenShift. He went from OpenShift to Ansible. So
oh, how the world turns.
Yeah. So here, it goes from running to provision. It goes from provisioning to provisioned to running, right? So some of these, if I do, this is the magic here. Get nodes. There we go. So we have 2 infras so far. They're not ready yet.
Nice. Okay.
Right. So I've typed this so many. I typed this so many times that I actually memorized this. Get nodes with the label node role kubernetes.io infra. Wow. I don't know. I memorize. That's like muscle memory now. So yeah, these are coming up. So I do sets. So I get machine sets, right? So here it gives you the machine sets. If I do machines, it says now that I'm running. And then if I do, so one of them's ready. Let's put a watch on this.
Mm-hmm.
Ready, not ready yet. So a few things that are a little different from version 3 to version 4. In version 3, the roles will just have the infra and not worker. In version 4, it has to have the worker because again, two things. Infra is not a thing, right? An infra node is technically, it's not like it's not an entity, right? Infra is just what we call a specialized worker. And for that matter, if you do an OC get machine config, which MCP, what stands for machine config pool, is we only have masters and workers, right? So in order for the infra nodes to get an update, they have to be part of the worker pool, right, for this configuration, right? So this is more on the side of Rel Core OS and Ignition and all that stuff. And we should probably do a Twitch on just Core OS
we need
and Ignition.
To. Like, we do need an Ignition Twitch.
Yeah.
You're absolutely right. Yeah.
But
just a time check here. We are just a little over an hour in. So yeah,
okay.
Top of the hour is cool. Diane's time.
All right.
For OpenShift comments.
That's cool. We're almost done here. So let's,
okay. Cool.
So I think we're right on time.
Yeah.
So now we have infra worker, right? So if I do an OC get OC describe nodes in a grep taint. So notice I have the node function infra no schedule, node function and no schedule, node function schedule, right? So let's see here. So real quick, OC get pods, all of them, wide grep. So there's certain workloads that are running on this already. So for example, OpenShift node tuning operator. So why is that running on the node if we have a taint on it? So let's go to OC project, this guy here, OC get, I think it's DS, yeah. So if I take a look at this daemon set, it has a toleration. It has a toleration of exists. So what does that mean? So let's take a look at the...
Yeah, what does that mean? Operator exists.
So the operator exists, right? The key effect parameters must match. You must match and leave so since there's no key in effect, exists meaning, it essentially means, there should be a good doc for this. Maybe I'll write a doc.
Scroll down. If the operator parameter is set to equal... Yeah.
It's set to exist. The key parameters are the same. The effect parameters are the same. Essentially, if you just have tolerations operator exists, it'll tolerate any taint.
Okay.
What you're saying is that exists meaning if there's a taint, I'm gonna tolerate it.
Cool.
And that's how workloads. That's how you do OpenShift handles, like things like Multis, SDN, the node tuning operator, things like that, right? And so
also meaning that if you added any key in there, any specific key, then it wouldn't be matched to the node.
Right.
Correct. Yes. So, all right. So we're almost done, right? So now how do you move workloads over? Let's go back to the doc.
Shift some important stuff over.
Yeah. So in that
also, I do have a cluster sitting here.
Oh, there you go.
You know me.
Moving resource to infrastructure machines in the same doc, creating infrastructure machine sets. There is a doc to show you how to move infrastructure machine sets, right? So that's moving the router, right? So that's number
perfect.
One, right?
Yeah, that's super important.
So remember that oh wait, no, that was the other cluster. We need to check the other cluster whenever that comes up. Bootstrapping still.
How many clusters?
How many clusters do I have?
Yeah.
So let's there we go. Let's edit this.
So yeah, there's a question about the fact that the infra nodes need to have the worker role too.
Yes.
Mm-hmm.
Yeah, so yeah.
Yeah, they have to. Yeah.
They have to right now in the current version of OpenShift, and probably the next version they absolutely have to.
Yeah.
So Christian, you said that in OpenShift 6, it's gonna be different.
Yeah, in OpenShift 6, you just think about it and it happens. So it's
right. You just say, "Hey, Dingus, cluster," and there's a cluster. Hey, Dingus, move stuff to infra nodes, and it spins up all the infra nodes for you. Yeah. That's the roadmap for OpenShift 6. I'll let Mike Barrett know.
That's right. I'll let Mike Barrett know.
And the reason why is that the field said, well, the chat
Oh yeah, the chat told us to.
Yeah. That's our justification.
We did a market survey on Twitch, and they said that.
Yeah, that's what they want. So give them that.
Give the people what they want, right? Let them eat cake.
Yeah, let them have it too.
Node placement here, essentially. Here, I can probably just copy and paste this, right? Copy pasta, make sure it's indented.
Yes.
Well, although I'm not sure that the indentation from here is going to be.
Yeah, I want to make sure. Come on. Eventually, I'll get this right.
Go to the start of the line.
I'll do this. There we go. Cool. So no placement, and then again, remember that won't work. So I'll add the toleration here. I have this. I can copy pasta this here. This isn't right. Is it there? No, still more. Come on. There it is. So tolerations, node function equal infra, no schedule, right? So that way it tolerates that. So here, is that in the right line? Node selector. Oh, it needs to go in one, I think. Yes, it does. Let me. 2. There we go. And then let me visualize this. Oops. And then there we go. That makes sense to me. Okay, cool. Node placement, tolerations, all that good stuff. So this is the magic moment here. I'm going to set the replicas to 3 because why not?
Because yes.
There we go. So let's do OC get pods -n OpenShift.
This is a good question in chat too, Jaafar.
All right.
If the infra nodes has a worker role, the application pod may start on the infra nodes. Yes, no, maybe.
So this is why Christian is setting the taints and tolerations.
Bingo. So those taints and tolerations will make sure that the application work stays on the quote worker nodes and not on the infra nodes, or doesn't make its way over there.
Yes.
Yeah, so the taints and tolerations are the most important part.
Because you are putting the taint on the infra. Only the workloads that have the toleration will be able to get on there.
Okay, OC get pods and then -o wide. Okay, so then now let's do OC get pods. No, OC get nodes. Oh, with the label. Okay, so let's do this. I'll just try to figure out the best way to clear OC get pods.
You want to do, Christian?
OC get nodes. I want to show the nodes and the node role.
Sorry?
Pods.
Nodes and pods?
Yeah, node role Kubernetes.
I think if you do.
There we go.
Oh, so, you want to?
Yeah, I want to show. So this one is running on 160, 213, and 54. So then we need to delete this.
So if you do OC get pods -o wide.
Yeah.
Does it tell you where they run?
Well, I want to delete the router so that way it'll try to run on the.
Okay.
Yeah.
So yeah, just use the selector like the label.
Yeah. The label's the -L.
Yeah.
What happened here? That's quite a long pause.
Well, the routers
it's moving them, correct? Right?
Yeah,
like it's in the process of spinning them back up someplace else.
Yeah.
Yeah.
And that's where you hope that you didn't mess the configuration.
Yeah, this is where I hope it doesn't mess up. Yeah, because then I'll get all kinds of crazy stuff going on. So if an infra node has a role of infra label and its machine configuration points to a worker config, it should be yes. Okay.
Yes. Yeah. Confirmed. Thank you, Waleed. Again, we still owe you shirts.
So if the infra nodes are okay. So that took a while to delete. So let's try this again. Let's see if this worked. All right, it's running on. Oh, I wonder if it's tolerating 213. So let's go to OC get events. Let's see what I missed here. Didn't match node selector. Didn't match pod affinity. 3 nodes. Taints. Did not tolerate. Did not tolerate. Why did not? Yeah, and it did it again. Did not tolerate. And then I guess it just does it there. So let's edit it again. Toleration should go somewhere. Oops, I didn't want to do that. I did this last time.
Learning in public.
Yeah, I did a watch on an OC edit. I don't know why. Oh, I know why. Because I'm dumb. Okay.
You're not dumb.
So I put it under the status instead of spec. So this is what I did. That's why I accidentally put the config under status instead of spec. So
whoops,
I didn't change anything. Essentially. So luckily, since this is a cooking show.
So usually if you're doing it, like if you're doing OC edit, you're gonna have an error instead of so.
Yeah.
You are editing the YAML file, and you're not gonna get that. But if you do an OC edit and try to change the status, it's gonna say that it's a read-only field or something like that.
Okay. Oh, something's happening here.
There's some cooking happening.
No,
oh.
No cooking.
Oh,
come on.
Come on,
little guy. You can
come on now.
Come on. Let's do. I'm gonna do heavy-handed again.
Do an OC describe or?
No, I'm just gonna delete everything.
You're just gonna kill it all.
Kill it all.
Okay.
I
mean, they are pods.
Yeah, well, pods.
Pets.
So it's.
They are pets. Yeah. Or cattle. Sorry, my bad.
Poor pets.
Poor pets.
Poor pets. So I'll let because I want to do this heavy-handed, so that way.
No lingering issues.
No lingering. No, none of that.
Yeah,
so
no craziness. Yeah. No, that's my thing, right? Like, remember back in the day when you installed like Linux boxes and you wanted to like have a clean Linux install and you were constantly like reinstalling Linux.
Reinstall it over and over and over again.
Right,
yeah.
because you were installing crap and it didn't work and you're like, crap, how do I clean this up?
Yeah, okay, yeah. Well,
same process, right? Like you want to blow all this stuff away, make sure it's all clean and nice and neat. Right? Like that's basically what you just did.
Make it all good. Also, I think there's a dependency. So the reason this takes a long time because I'm deleting the routers is there's a dependency from the API server to the router, even though they're running on different things. I haven't quite figured that out yet. Okay, so then
things have changed.
Things have changed. I wonder why it gives me 4 instead of
I don't know
3. So let's do.
Is it?
So can you describe the one that is
described? Yeah, I want to see the one.
So it took.
That is not ready.
It took the spec. So the spec has that.
Okay.
You want me to describe? Oh, it's terminating now. Okay.
Oh, okay.
We just gonna give it enough time. So so the router, we won't count the terminating one. It's running on 47, 155, and 144, which we have 47, 155, 144.
Okay.
So
cool. Matchy.
And those are the ones that you created as infra?
Yeah, these are the infra nodes, right? Because I did infra worker. So 155, so that's there. 47, which is there. And then
160 is going away. So.
160 is going away, yeah.
Eventually. It seems like
eventually it'll go away, yeah.
I wonder what it's rerouting, right? Like, is it offloading traffic or something?
It's offloading traffic. It's doing something, right? So this workload now tolerates this taint, and then you can go to other things like the registry, right? So the registry, same idea. I think it's config cluster. Yeah. And then
node selector.
For the registry.
Yeah, image registry, replicas 2.
Okay.
I think it's under spec, right? They want you to do under spec config. Add the following lines under spec. Okay, yeah. So spec. Yeah, so same. Selector spec. Yeah, same idea. So the node selector spec.
Not status spec.
Not status. Don't put it under. They start with S. Okay, they both start with.
I know.
I'm just looking for the first.
It's funny the little landmines we trip over, right? Like,
yeah, it is. Yeah, definitely.
Like just mentally with all this stuff.
So that's the one. Yeah.
Oh, there you go. Drop in chat there.
Oops.
That's
so tolerations. Yeah, so the same thing. Add the toleration. So in the doc, it doesn't tell you. It just assumes that you're just adding the label. But since we're advanced users here, we like to add taints. So we have to add the tolerations to the worker too. So
that ensures something that was mentioned before. So yeah, if you just add the label, it's gonna move the workloads or the router, the registry, etc. But it's not gonna prevent anything else from being deployed on the infra.
Wish I could make that not clickable in chat somehow.
Oh yeah, like
it auto does it
tick or something like that.
Yeah, it's weird. Chat being chat.
What's the image OC project? There we go. Image registry.
And
I think I'm going to switch to a cube, right? kubectl get pods. We have 2 image registry running. Oh yeah, let's make this 3, right? So replicas 3. Where's my tolerations? There we go. Tolerations in my node selectors. Perfect. Yeah, so it's draining now. So let's do registry. OC, get pods, show labels. I don't want to see everything else. There we go. Docker registry default.
Sweet.
So if I do kubectl, get pods -l. So I got 3.
Further proving that OC and kubectl work very well hand in hand.
Hand in hand.
And there they are.
There's 3.
Where are they?
Good question.
Prove to me.
Yeah. Prove. That's we're the. Aren't you in the show me state?
No, the show me state is Missouri.
Oh, Missouri. Okay.
Yeah. What are we?
You are the hand, right? The glove.
Yeah, we're the glove. Hey, what's our state motto? My whole family's right in front of me.
Oh, okay. Yes.
What's our state motto? Do we know, Michiganders?
No one knows.
None of them know. We don't know. I've lived here for years. They don't know.
Yeah.
To be honest with you, I don't know either, so I can't blame them.
Yeah. Okay. I need the O wide, right?
Yeah, the O wide.
The bad road state.
The bad road state. So
are you serious? Wait.
Oh, we need to delete the other ones.
No, well, I know. If you seek, okay, say that again.
Wolverines. Oh, you are Wolverine.
If you seek a pleasant peninsula, look about you. That is literally the state motto. Thank you.
There we go.
Yep. Oh, the 4th grade teacher knew?
Yeah, the
2nd grade teacher did not.
Yeah, exactly. So
JP Dade, that's very offensive, by the way.
Don't drink the water state. Wow. All right. So here's a perfect example about the effect, right? So remember that we set the effect to no schedule, right? New pods that do not match the taint are not scheduled to the node. Existing pods on the node remain. So we scaled it, right? So we scaled this workload, but 2 of them stayed on the original node. This one, scheduled on the new infra node. So so that's the reason why it didn't move the entire workload, right? So if I do kubectl delete pod all, right? Hopefully I'm in the right. Okay.
Oh, yeah.
hopefully I'm in the right namespace.
Deleted some stuff.
yeah. I'm like, well, I mean, it's Kubernetes, so then
it'll bounce back, hopefully.
So it should come back. So
there we go.
Oh, you're removing the certificates.
Yeah. I'm removing all kinds of stuff. So so here 47, 144, 155, 47, 144, 155. So so yeah, that workload is moved. For the sake, there's a monitoring solution. So the monitoring solution is a little easier because you just create a config map.
Yeah.
So let's do it. Might as well do it here. I'm gonna delete these directories anyway. cm.yaml. And in this one, this is a little easier. You can just add the tolerations here, right? Since this is...
You can check. Okay, you got it.
Yeah. So here, oops, Control V. Control V. Eric has had me using Shift V, and now my muscle memory is off.
Your muscle memory's off? Rough.
It's rough times. Well, and also I use control as, sorry, I use caps locks as control, so I remap.
Right.
And it's right next to Shift, so I sometimes...
I feel your pain there.
You feel the pain, all right?
Yeah. This is why I hate remapping keys on keyboard, because I will always mess up something.
Well, and it also sucks when you're using someone else's keyboard. It's like, why is your keyboard broken? In my head, I say,
no, my keyboard's broken.
So my first admin job was administrating Solaris servers, right? So if you ever worked on a Sun keyboard, control is where caps locks is. So anyway.
Yeah, it's and those Sun keyboards were like deadly weapons. Like
really
tornadoes would pick them up and put them through trees, right?
Yeah, exactly. So so yeah, here it says add the node selector, but obviously we're adding tolerations. Just to note, tolerations, and I'm pointing at my screen like you can see, tolerations and node selectors are on the same level. So yeah. OC create. Oops. Do I do an OC create or cube create?
Always do an apply.
That's true. An apply would be good.
Yeah.
Well, what does it say?
Someone from the team to use apply. So.
Well, it says create on the doc.
It does say create on the docs.
But let's do
you can do apply.
Let's be a good citizen, yeah, and do apply. So there we go. So then the config map is created, and then it says to run a watch on this guy here. This one will take a while because there's a ton of components.
Whoa.
Yeah, there's a lot of components for the monitoring stack. There's like the alerting manager. There is the node exporter, right? So it's exporting all those things. There's Grafana that's part of that. There's it's a whole stack.
Yeah. So like what is this? This is monitoring. This is alerting. This is the container. The image registry.
All that good stuff.
All that fun stuff.
So
so things that make OpenShift, yeah.
Things that make OpenShift, yeah. So moving the cluster logging resources, right? So I don't have cluster logging installed, but if you did. If I did, this is how you would do it, right? So
but can you show that they are installed with the operator, maybe?
Yeah. So the logging stack isn't installed by what do you call it? By default, yeah. Not on install. It's a post install. The reason for that is because there's storage involved, right? There's storage involved, and there's actually planning involved. If you think about like your logging stack, how much storage. How long you want to keep the logs, if you want to ship those logs somewhere else. Yep, there's actually a lot of planning than just installing.
Like there's no one size fits all when it comes to logging, I feel like, right? Like everybody has their thing.
It completely depends on your workload.
Yeah.
And so so let's see if so look at that. Let's just you know what, with 30 minutes to spare, we have this cluster installed, right? So let's echo a kube config. All right, cool. That's another setting. I want to make sure I'm not on the so drum roll, right? So this is the one that we did at install, right? We want to install infra nodes at install. You need a soundboard, right? You need like a drum roll sound. You need like a soundboard that does different things.
Yeah, no, I wish I really do wish I had like a soundboard with drops.
Yeah. So if Chris Morgan's, we want approval for
next time I'm gonna play a guitar riff.
What's that?
Of course, getting one of those would probably be a really hard like ask right now.
You just tell me which guitar riff you like for that.
Oh, there you go. We'll get Jaafar on here playing guitar.
We're not drummers, man. We are guitar players.
So QCL get nodes. All right, drum roll, please. Did it work? Yes, it did. Look at that. We got infra nodes at install.
Nice.
So let's make this look nicer. Node roll, Kubernetes.
The hardest word to spell in the universe.
Yeah, Kubernetes. There's so I know a guy Red Hat, a Greek dude. He says that we're pronouncing Kubernetes wrong. So.
Oh, I'm sure we are.
Yeah. It's like a Anglo-sized version of the actual word.
I would not doubt that in one way, any way, shape, or form.
Yeah. So we have infra nodes at install. So let's see.
That's why I only say OpenShift.
Yeah, OpenShift. Yeah, that's right. So say OpenShift. Yeah, exactly. Instead of Kubernetes. So here, so we have that on install. So remember, during the install, we wanted the router, the ingress to run on the work, the infra nodes. So let's see if that happened. I've been testing it. Hasn't happened yet. I don't know why, but here we go. kubectl get pods, OpenShift router. What is it?
I think
Ingress
router.
Ingress.
Ingress. Okay.
Yeah. No. OpenShift -ingress.
Okay, there we go. Clear. Okay.
Where's it run?
Okay. Nodes.
No.
Yeah, I want to get the nodes first. Yeah. So get pods. OpenShift ingress -oy. There we go.
Yep.
So it's running on 30 and 22. No such luck. Yeah. So I modified. So you guys saw it. I have proof. I have video proof.
Yeah.
I modified the ingress. So let's take a look. Let's see if it's there. I want to. So yeah, spec. There's nothing in the spec. Replicas 2. There's no selector, right? There's no node selector.
Weird.
Yeah. So if there's any engineers, I'm pretty sure they're plenty busy because there's a release pending. But but if there is one, I don't know what happens. But
I mean, is that a bug or? Do we need to open a ticket on that or not?
I'm going to file a bug.
Okay, you are going to file a bug.
Yeah, if it come back, that's expected behavior, then that's fine. But I would think if I modified the manifest, it should.
Right. If I did it on install, you should shift the load.
Yeah.
That would be my. Maybe there's a reason why they don't.
Yeah.
I'm sure there is because it's like common sense, I would think. But
yeah, I would think. I don't know.
So yeah, you can tag me in that bug report too, and
I'll tag Jaafar too because he was asking earlier about it. Actually, yesterday when we had a call about this Twitch stream, but yeah. So
what did I do again?
What's that? Yeah. What do I do again? No, we're actually streaming now, Jaafar.
If you didn't know,
this isn't a test run. Yeah,
it's for real.
So we have the so just to recap.
Yeah, please.
We have the kubectl get nodes, right? So we have the infra nodes, right? So we created an infra node out of the machine set. When we take what we also further did is we added a taint, right? So So that way only certain workloads can run on this infra node. And then what's the ingress? And then we added a toleration for those specific workloads. So so it's not enough just to add the node label. You also have to add taints, and then you also have to add those tolerations and those node selectors on your workload to have truly infra nodes, right? You can do
infra nodes,
yeah, to have infra nodes that only has the workloads for your infra nodes, right? Things that can run on the infra nodes are things like the router, registry, logging stack, monitoring, alerting stack. You can also run, and I found this out, Quay, right? So if you're gonna run Quay, that's eligible to run the infra nodes. You can also run OCS on infra nodes as well. That does mean you're gonna have a lot of infra nodes, because some of those workloads require a lot of compute, but we won't charge you for those cores, right? So it's you won't get double charged, right? So if you buy Quay and decided to run on OpenShift, we're not charging you for the nodes and for Quay, right? You don't get double charged. You can run those on the infra nodes, and you won't get a subscription ding.
And for OCS, you're probably gonna have dedicated nodes just for OCS, labeled as infra nodes.
Correct. Yeah. Exactly. If you're running OCS, what we call it integrated mode, which is the only mode right now, which means it'll run on the same plane as what do you call it? As OpenShift, right? So it's all integrated. And if you're running OpenShift virtualization, that's just like a whole nother topic. But
we did do a stream. Did we not do a stream on that? I'm pretty sure we did a stream.
I don't know. Andrew, did we do that? So there was a question here. It says, "What if you're on the old socket model?"
Socket model for pricing?
Yeah. So
Jafar.
So the old
ideas?
Jafar. I don't know what it is in EMEA. I know in North America, anyone who's renewing, I don't know how long we're going to keep the old socket model pricing around.
Right. For. Yeah. Like
so there's a conversion rate to convert sockets from sockets to cores, but to my knowledge, with OpenShift 4, you only get the core.
That's it.
The core pricing.
Model. You cannot subscribe based on a socket model, so you have to convert your entitlement to cores.
There was a grandfather pricing that happened, but I don't know how long that's going to happen, right? So
was your or Waleed, please check in with your normal
check with your rep.
Like that should ask them that question, and they can help you get.
They can definitely help you. And
pricing and conversion and everything, because Lord knows
philanthropist or whatever his name is. So like that's what happened. Used to be on the socket model, but we had to switch to core pricing. So it depends. I think there was one cycle where you could grandfather in, but other than that, I think beyond that, I don't know. Again, check with your rep.
Check with your rep, please, because like that. I'm wondering how you're still on that model, but whatever. We're everything's in flight. It feels like a day is a year nowadays. So
So then there's
what else you got for us?
So anyways, that see here, you guys have any questions or
enterprise frame agreements? Okay.
So let's see here. If there's any questions or any comments, concerns, you guys want to vent or something?
Any estimate on when Ceph operator might become available as the alternative to the converged install of OCS?
Now you need to get the storage guys on here. That's a good question.
I
have no idea.
I should get OCS folks on here. You're
get the OCS guys. We have ACM coming up. Maybe we should get some OCS guys.
Definitely need some storage folks on.
An announcement about OCS being available outside of OpenShift now, like bare metal?
Yes, I believe so.
There's a plan of having it outside of OpenShift, but right now you can only get it in converge mode.
So the Ceph operator, I'm not sure which person or who maintains that.
Is there an open source Ceph operator?
I think so.
That'd be cool.
I think it is open source. Like, let me actually.
There's an open source operator. Yeah, I don't know
if I could find Operator Hub real quick.
Yeah, what's really cool about the Operator Hub is it's like people constantly putting stuff on there.
I guess you were speaking about the Rook operator.
Oh well, yeah, you can use the Rook operator.
Yeah, there's a Rook
operator. Yeah, Rook Ceph operator. The Rook folks make that. So
yeah. So you can use it. You'll get your support via. I don't know if they offer support directly or if it's only only community.
The Rook authors info@rook.io. So yeah, it looks like community support.
I think it's the same guys that do Crossplane, right?
No. Rook is a different company than Crossplane.
Oh, okay. Is it?
Rook is the storage company, right? Like I met them way back in 2017.
Oh, Upbound. See, they're top contributors. That's what I was thinking. They're contributors. Upbound.
There you go. That's why. Yeah.
Yeah, these guys here, who also do Crossplane. That's what I was thinking. Anyway, yeah. So it's just
check that out. I mean, maybe that might help.
Check that out. Maybe that works for you. There's also Portworx, I think.
Yeah, Portworx is out there. They're like the number one.
Portworx Enterprise. So
see the provider, I think, or whatever. Maybe.
Yeah. So the cool thing about the Operator Hub is that we're getting ISVs to offer their solutions on OpenShift via the Operator Hub, right? So if you find a solution that you like, or like if you're working with the ISV, so for example, App Dynamics, right?
Mm-hmm.
You can install their operator and it's certified to run on OpenShift, but you get your support through App Dynamics still. But it's certified on OpenShift. So
right, like you get the support through App Dynamics, and they are saying yes, we'll make sure this works on OpenShift the way it should.
Yep.
Yeah.
So
there's marketplace.
So say that again.
Yeah, I said if you extend it to the operators marketplace, which is something that's coming up.
Yeah.
You could also subscribe directly from the OpenShift.
OpenShift, yes.
Yeah.
Operator.
So operator controllers, should they run on Infra nodes? No.
Operator controllers, should they run on Infra? No.
No. And why is that? Because there's only certain stuff that should run on Infra. And operators are typically considered workload, even though sometimes they can be infrastructure related, right? I know that can be like a confusing dynamic there.
Yeah. So technically, technically speaking, the ingress and the image registry and the logging monitoring stack, all of those are operators. So like your partly are.
Yeah, like it is. I understand the confusion there.
But but like these operators, no, they would be considered workloads.
Those are workloads. Yeah. Even though it's like you wouldn't think they are, like an Argo CD GitOps kind of thing, right?
Like
that is considered a workload.
It's considered a workload.
Yeah. My Couchbase operator, my best friend.
Yeah.
Long story. Anyway, so let's see. So remember, the infra nodes are free. Right, as long as you're not putting extra workloads on them. You can do them at install. You can do it post install. Some issues with the router moving over during when you do it at install. So we'll look into that further.
And I have video proof. The reason I wanted to show it is because I have video proof.
Now you have evidence, right?
Yeah, now I'll just link them to the YouTube video.
There you go. It'll be here on Twitch for 60 days, and then you go to YouTube for the remainder of the time.
When I fill out the BZ, I'll say, here's my
Put the Twitch link.
Yeah, put the Twitch link. I'll just put the Twitch link. Yeah. I don't have to type all the stuff out. I just link it directly to the video.
You can share it at the exact moment in time that it breaks.
Yeah, exactly. I could do the seconds equal, whatever. Yeah.
Yes. You should totally do that.
Yeah, so I'll do that.
Do it for real. Example here.
Yeah. BZ, the first Bugzilla with video proof.
With video evidence.
Video evidence. All right. Nice. So I know you have what, Commons up next or something like that?
Yeah, there's so up next we have OpenShift Commons briefing. What's new in the operator framework, right? And if you're not familiar with the operator framework, you should be, right? Writing your own operators is entirely possible, right? We've actually made it even easier because you can write your operators with Ansible. So if if you're into operators at all, please stick around. We're not going offline. We're just going to stay. We'll be right back here. So
stick. What can you what do they call it? What do they call it in Twitch land? I'm feeling my age. Rush? No.
Raid. No,
raid.
I'm
Can
not.
you raid
I'm
your
not,
own channel? Can you raid your
I'm
own
not,
channel?
I'm not ready for raids yet.
Yeah,
I don't think.
okay,
I don't think. We can.
Okay, gotcha.
I don't know if we have the yes, we can do raids, but we haven't.
We raided the IDM
yet.
guys earlier.
Yeah, we did that,
once.
but that was just like. Was it actual raid?
We actually Eric did it. Eric
did it. That's right.
We raided the IDM guys. Yeah.
Okay, cool.
Just out of curiosity, for among the viewers who are actually following the channel, how many?
That's right.
Yeah. So we have a goal. I'm sorry, I should have mentioned this in the very beginning. We have a goal of hitting 1,000 followers for Twitch. So go to twitch.tv/Red Hat OpenShift if you're listening to this. Hit follow.
Just click on the lovely heart.
The lovely little heart.
Yeah, heart. Give us a little heart.
Like I'm trying to hit that 1,000 number by the end of June. I'm not going to say it's not going to happen because who knows, but like I'm getting desperate.
He's getting desperate.
The stats are making me worried. So
So
please tell your friends. Like you saw a great presentation here. There's another great presentation coming up. Don't you want to know about these things?
Yeah, know about this. Yeah, exactly.
Right? Like you can do it silently in the background if you want, right? Like you can tune your notifications how you want. You can get emails or not. Your call. Just hit the follow button, and we really appreciate it.
Actually, is you could hit the follow button and just click on it back on July 2nd.
On July 2nd,
no, don't do that. What would be even better, Jaafar, is if you hit the follow and then the share button.
There you go.
But I can only ask for so much.
That's right. So don't make Chris Short sad. So
make Chris Short happy. Hit the heart. Yeah.
Cool.
Awesome. Thank you so much for joining us today.
Hey,
everybody that is on the call, stick around for OpenShift Commons briefing up here at the top of the hour.
Thanks a lot. Hey, Chris, look at the followers number.
Oh, you want me to actually look at it? Did it jump?
Yeah, it did.
We are at...
Sorry, I got to actually open another tab. Hang on.
888.
That's a good number.
There we go.
All eights.
Nice. So we're getting
on
close.
Our way.
We're
getting close.
All right, everyone, stick around. Thank you, everyone.
Yeah.
Thank you.
Thanks a lot. Thank you very much, and stay in touch. Christian and I are cooking up some nice sessions for you on Tecton and Argo City.
Yep. We'll be back. Me and Jaafar.
Oh yeah, I can't wait. Like the whole GitOps thing. It like me and GitOps, Christian, right? Like you know how much I love that whole concept and everything. So yeah, I'm looking forward to that for sure. Bring it.
Cool.
All right. Yeah. Even Waleed says yes, please.
Yes, please. Yes.
All right. So thank you all for joining. Don't go too far. We'll be back here in a few, and I'll catch y'all. I'll catch you, Christian and Jaafar. I'll catch y'all on Slack.
All right. Yep. See you. Bye,
Thank you.
Thanks again, Christian and Chris.
Yep.
And awesome job, Christian. It was a great session.
Sweet.
All right, everybody, welcome to yet another OpenShift Commons briefing. And today we've got Rob Sumsky and some other guests, and we're going to talk about what's going on in the operator framework world. That's OLM and SDK and lots of other good bits. So Rob, I'm going to let you introduce yourself, talk it for as long as you need, and then we'll have live Q&A and a conversation afterwards. So take it away, Rob.
All right, sounds good. Hey, everybody, I'm Rob Sumsky. I'm a PM for OpenShift, and I've been looking after the operator framework since it was announced as part of CoreOS several years ago now. So I'm here to give you guys an update on some exciting news, what's going on technology-wise, feature-wise, and when you can expect certain things. So we'll jump right on into it. The first big news is I think we've got enough votes, and I don't think it's official yet, but the operator framework is going to be joining the CNCF as an incubating project. This includes both, this includes both the SDK and the lifecycle manager. And so we're going to break down what each of those are and why they're important. But we're super excited. This kind of builds on all the momentum and open source work that we've been doing. Being part of the CNCF will be hopefully a big win for the project, get more users, more contributors, solidify this as the framework for managing operators across the Kube ecosystem. So we're super excited about that. So thanks to everybody that either commented or voted and was involved in this process. It was took a little bit longer than we thought, but that's always the case with these things. So yeah, we're excited about that. And so that's the first big news. Let's go jump in really quick, but I just always want to start with what is an operator, just in case you're watching this stream and you're not as familiar with this. And so at core, really an operator is a piece of technology that sits in the middle between users and a cluster, and it runs software. So in this example here, you can see the operators in the middle, and what the operator is doing is it deeply understands both knowledge on how to run a type of application, so like a MySQL database or a distributed system, a Kafka cluster, whatever it is. So picture all the operational knowledge needed to install that, to upgrade it, to scale it, to monitor it, to back it up, whatever it needs to do for that specific application. You build that into a piece of software that then outputs Kubernetes on the other side of it. So making all of the objects that need to happen, wiring them all up, generating secrets, storing those in the secrets in Kubernetes, managing the RBAC, knowing how to upgrade certain parts of the components in the correct order, using stateful sets when they need to be storing stateful data, using deployments when they're stateless, et cetera, et cetera. This is what the operator does. And so the operator framework is here to manage all of that, to help you build this piece of software, but then help you manage it and upgrade it over time, which is a really important part of it. And what we want to get to is a cloud-like experience. So, picture getting your favorite database or machine learning service from a cloud provider, but we want that to work against Kubernetes anywhere that it's running. So the operator is the key there. It's providing that cloud-like experience, but then interfacing with Kube, so you get this hybrid cloud experience at the same time. So that's what we're going after. So let's dig in a little bit further. So we see operators kind of taking off across every different kind of vertical you can have in software, because you want that SaaS experience, and all of these categories that you see on the screen here are just getting more complicated as software gets more complicated. Before you might have just run a single MySQL or a single Postgres in a VM against a local disk, and you backed it up every once in a while and maybe to a tape library, and that was it. Now we've got NoSQL databases. We've got all these big data stacks where you're scaling out different parts of the application related to load and how much you're storing. Monitoring solutions that need to react as containers are coming and going in milliseconds, and so the throughput there is really high, and also the how dynamic the system is very high. And so you need different ways of running that type of software to keep up with Kubernetes in this modern software. Messaging services are super popular in financial services and all these different systems that need to talk to each other, and so those become critical. Can you scale those? Can you monitor them? Do you know what's going on? Are you setting them up in the most secure way? All that really matters. And then lastly, I think storage is a really interesting one, because if you think about it, we don't want to be tied to a single local disk anymore. But in our Kube clusters, we actually have tons of local disks. As you have 100 nodes, you've got 100 or more disks. So what some of these storage providers do is slice up those disks into network addressable storage that the kube cluster understands through its PV and PVC mechanisms. And so you kind of run storage on the cluster for the cluster, which is really exciting. And that's a whole distributed system too. Ceph, Gluster, a bunch of other technologies are used there as well. So that's where operators play. I'm not going to throw up the logos of any of these, but every major vendor, I think, in all of these categories has an operator at this point. So take a look out. Our place for discovering those is operatorhub.io. This is a listing of a bunch of open source and community operators. Red Hat also certifies operators, and so you can find those inside of your OpenShift cluster as well, alongside all those community offerings and Red Hat products. So breaking down what the operator framework is, it's really these three main pieces. The operator SDK for building operators. So this is a new style of building software, interacting with Kubernetes APIs and how to best do that, as well as hooking up a distributed system into, operational knowledge embedded in code. And so what the SDK allows you to do is start with a bunch of scaffolding for code where you just have to bring the knowledge of your application. If you're a Postgres admin, you kind of know how to administer Postgres. So we're going to help you express that in either Go code, Ansible code, or in a Helm chart. And so that's how we help you build an operator. And so we'll talk about some of the new features coming in these SDKs, but they're pretty robust right now. And we've got a ton of folks that are building really interesting things with them. Next is the lifecycle manager. This is the thing that helps you once you've built this operator and it's packaged up, how to get it out to all of your customers. How do 100 different people go install this on their kube clusters? How do they manage it? How do they make sure that all the correct permissions and security is set up correctly? The lifecycle manager helps you do this. And then I already mentioned Operator Hub.io for discovering operators that have been published by different authors out there on the internet. So I talked about the SDK and how we have these three different flavors of it. There's Helm, Ansible, and Go. There are also other open source frameworks for creating operators out of Java and some other things like that. So if you're interested in your favorite language, there's probably something out there for you, and somebody has already started doing that. People have written these and all kinds of things. So a different part of the SDK than just dealing with writing code is all of the other important stuff that comes along with it. So how do I package this up so that I can go run it through a CI pipeline? The testing is really key here because if you think about it, this operator is going to be managing really important and really complex distributed systems, and that's why you're expressing it in code, but you want to validate that that code is correct. And so we have some tools that are built into the SDK, and the operators are instrumented to help you do things like, when I kill an important part of this, does the operator resurrect it? Or if I go mess with some important configuration variables that I need to ensure remain in place, does the operator go replace those back to what they should be? When I send a bunch more requests into my distributed system, does the operator scale up the correct component accordingly? Those are all things that we want to express in testing pipelines, and so that people can really test the code that they're writing, and then your customers can all just depend that, yes, you are orchestrating MySQL and Kafka correctly. So you can check this out. They're on GitHub under the operator framework org. And we've got, like I said, these three flavors. You see these arrows that go from left to right. That is talking about what we have, we call a maturity model. And the maturity model is just how smart is this operator, basically. And it depends on each application kind of where you need to fall on this, but installing and upgrading is kind of, you mentioned on all of them, and that's really the bare minimum. I need to be able to install whatever this application is and then update all of the components of whatever the application is installing. So this is for a traditional like scale out database. This might be, the MySQL and Postgres processes themselves. Any authentication and rate limiting proxies you might have in there. If you have read replicas, updating and orchestrating how those are all connected together, all kind of falls into that. And so all of our SDKs help you with that part of your application lifecycle. Now you see the day 2 operations term mentioned for Ansible and Go. That refers to all of the other dynamic reconfiguration that you would do for any sort of application. So in the database example we just talked about, what if you started with a single node and you installed and you could upgrade that, and that's awesome, but then your app actually start getting
recording has started,
and you need to go out and add a read replica tier, or I actually didn't need this to be HA, but now I want it to be HA. All those are day 2 operations where you can say, hey, operator, just start backing up this thing. Hey, scale it out automatically and have the operator do it. That's all day 2. And then you start getting into smarter stuff. So metrics and alerting, orchestrating, monitoring pipelines, doing automatic tuning of the workload based on how it's running are all really important. And so that's where you need higher level primitives in the SDK and the language that you're using to express all that logic. And so that's where some of these different types of code bases can work for you or against you, depending on the type of application that you're running. Jumping over to the lifecycle manager. So once you've done all that, you've built your operator and you've written all your code, you would think, oh, I just need to run it, right? You just go put it on the cluster. Well, there's actually a lot of different needs here related to running and installing these operators because you've got different personas that are involved. So I've got the 3 kind of main ones here at the top. I've got an operator developer who might be building an operator either internal to your organization or is tweaking something about an operator, and they have very specific needs where they need to, they want to test against a live cluster, and so you've got some things that they can do there, especially if you want to register it with a catalog. You've got a cluster admin who is looking after the whole cluster themselves. They're probably not experts in all of the applications that are running on the cluster, but they do want to ensure that if there are certain CVEs in some of the software that's running on the cluster, that stuff stays up to date, and managing dependencies between some of the teams may be at a very high level. So you need to update all these operators and get a good sense of how healthy they are, what's going into those updates, if there is any security content in there, et cetera, et cetera. So that's kind of the purview of the cluster admin. And then the cluster user really just wants to run databases and messaging queues and storage services or whatever it is. So they just needed a mechanism for discovering which operators are installed on the cluster and then interacting with them. Hey, give me a MySQL database and this namespace and call it test, and then I want a different one with a different configuration in prod. And give me some graphs for all the monitoring that the operator sets up. That's the purview of the actual user there. So when you dig into it at the very bottom here, you see there's bubbles for dependency resolution, CRD lifecycle, and collision detection. This is where you start to need a system for installing all these operators, because what they're doing is they can depend on each other. So you might have a serverless operator that's running Knative, which is a serverless framework for writing functions and having a event-driven application. But that actually needs a Kafka queue for it to consume its messages, and so it might depend on a Kafka operator. And remember, you as a cluster user don't want to be an expert in either one of those things because you just want to write your event-driven application. So you install these 2 operators that actually depend on each other, and so the cluster admin can help manage some of those dependencies for you. And OpenShift has this dependency resolution built in based on the lifecycle manager. And then what these use at the core is the CRD, which is a custom resource definition. And that is the ability to plug into the Kubernetes whole model for doing RBAC and extensions to the core. And those need to be lifecycled. So they have versions, just like a deployment and a stateful set and a pod have an API group version and kind. CRDs have the same thing, and so they need to be upgraded and managed as they might go from alpha to beta to stable, or as new features in Kubernetes come in, like some of the new validation logic that was just shipped, where you can say, this is a field as an integer, and I want you to enforce that, upgrading into all of those new capabilities as well. And then lastly, you don't want 2 operators colliding over trying to manage the same type of resource. So if if there were 2 Kafka operators out there, you don't want them both trying to operate on the same Kafka cluster. So there's some collision detection that's built into the lifecycle manager, and that's really just to protect the cluster from itself. It really kind of happens all under the hood without you really having to notice it. That's a quick overview of kind of where these 2 pieces of software sit and why they're so important, and then let's go into some specifics about new stuff that's coming. So in OpenShift 4.5, we are first introducing a new bundle format for operators. And the bundle is really all the metadata that those two systems create in order to install and upgrade and manage operators. So this is really on an operator author is the person that's really going to interact with this. And the exciting thing about this is it just breaks apart some of the dependencies we had on these manifests that you had to build, so that they're a little bit easier to run. And what's really exciting is they're actually going to be packaged just as containers, just like anything else on the platform. And so when you build an operator release, you'll have all the kube objects that represent all the RBAC that this thing requires, and here's the service accounts I want you to create, and here, I can be installed cluster-wide, or I only work in a namespace. All that metadata about how it works is bundled up into a container image, and then you can just mirror that into whatever container registry you want. So OpenShift will have, some bigger bundles of these operators, that represent our certified and our community operators, but you can also just build, your own and distribute them. So one of our partners might want to do that, for example. And so all you do is you pull this container and you register it in the cluster and say, hey, this is a new operator that I want to use. It's represented by this container image. Make it available on my cluster, and it goes. You can see this new operator object on the right-hand side makes that happen. We're also going to be using this new format on Operator Hub and kind of build it into all the tools. So the SDK, builds these things, OLM knows how to run it, etc. So that's really exciting. It's kind of more under the hood, but it matters if you are building an operator. The next is new capabilities inside of our package manager tool, OPM, to start building customized versions of all of these. So instead of just, a one-off operator ships version 1 and then version 2, you at a big bank or insurance company or something like that might want to curate your own set of catalogs. These are the operators that we have tested and we know are high quality and work well. So I want to, allow folks to have access to these. We have a new tool called OPM that can help you build and push those to a central place. So you can say, instead of registering operators one by one, here is my entire private catalog of operators that I want to use in my cluster. This is really important for clusters that are in disconnected environments. So sometimes government agencies and financial services, things that are running like a stock exchange, aren't connected to the internet. And so you want to be able to use operators in that environment just like any other. So these catalog can be built. You can mirror all of the containers that are required into that specialized environment, and then they can use operators all the same. So we're really excited about that tool. So this is a bigger feature add for those specific types of customers. Then lastly, all these bundle changes are really all about introducing a new operator API. So before, if you were in the ecosystem and if you used some of these before under the hood, we have a bunch of different manifest files that kind of describe how this thing works. So the cluster service version, the CSV, is typically the main piece of metadata that we have. And that would describe, all of the CRDs that this operator uses under the hood and how to install them and the permissions and things like that. But then it was a little bit detached from the subscription information, which is how do you upgrade this operator? Does it happen automatically or does it happen manually? And then some other things about how that actually gets installed on the cluster. So we're going to go unify that all into a new operator concept. So this is going to be really exciting because, then you would just say, OC or kubectl get operators instead of having to go look at all these different objects and kind of piece it together yourself. It'll all just be right there. Work just like, you would say get pods. You're not going to go hunt around to 4 different objects to try to figure out what's going on with your pod. So we're pretty excited about that. A lot of under the hood changes, but it's going to be a big UX win at the end. One of the last big things coming in OpenShift 4.5 is a bunch of scaffolding around admission webhooks, or webhooks in general. This is key because if you're familiar with the kube extension mechanisms, you can actually plug into a bunch of the deep parts for like when every single object is created in Kubernetes. You can have a yay or nay on whether that object gets created, and that's called an admission webhook. And these webhooks are really key to doing advanced functionality because you might want to block every Postgres CRD, so this a custom object that an operator uses that doesn't have 2 different required pieces of settings in there. You might want to say, hey, go reject that, and somebody needs to go resubmit that with the valid settings. And this might not just be that both of those exist, but the values of them can be compared with custom logic so that you know that it is actually truly valid. An example of this is JetStack's really popular cert manager for doing Let's Encrypt certificates for PKI. Validate some of the settings against other things that you pass in so that it knows that you're going to get a valid cert out and that your environment and the settings that you're passing in are actually able to create a certificate that they can issue. So that's really exciting. So what we do is we scaffold all these webhooks, and if you have to imagine, these have to have TLS and they're secured, and they're sitting in the critical path of kube operating, because it's going to ask for every object it's listening for, hey, go send off to this webhook and give it a yay or nay. If the webhook is down, you're not making any objects because it can't make a yay or a nay decision. And so what we do is we use the platform OLM and OpenShift to scaffold all of that for you. So we rotate your TLS certificates, we generate them in the first place, we set up all the routes and ingress for it to work, we run the pod that runs the webhook and all that type of stuff. So really, really easy. All you do is write your logic for the webhook itself. Mutating webhooks work the same way. You're basically mutating things instead of blocking admission of them. So if you wanted to set a parameter on every single object that goes to the system for like auditing or all kinds of things like that, you can do that. And you can also block mutation if somebody were to enter into a bad state for that operator, just like the settings you wanted to block on create. You can also do that on edit. So a good example of this is kubedb is an operator that helps you run DBs on kube, and it actually prevents accidental deletions. So it can look at the cluster and figure out if it thinks that you didn't clean up, you didn't delete all the objects, you just happened to delete this one critical one. Did you really mean to delete that? Or some behaviors that it can power. So that's really exciting. And then the last part of this is going to be in later OpenShift releases, which is the CRDs owned by an operator will be able to do conversion webhooks, which is kind of the last major type of webhook, which is when you upgrade a CRD from like an alpha to a beta or a beta to a stable API, you might need to mutate existing CRDs that are already in the cluster for them to meet that new standard. And so you'll be able to do those in the same manner in a successive OpenShift release. All right, so that's all in 4.5. Now I just want to touch a little bit more on the future and what's coming in the next year or so. And one of the things that we've been working on is an easier update graph. So if you picture when you're updating from version 1 to 2 to 3 to 4, some of those versions might be able to be skipped, some of them might not, some of them might not work with each other, some of them might have a bug later on that you want to revoke that update. So all the typical tools that you would use to like run a SaaS or to manage packages on a system, we're bringing into OLM. And so we have a lot of that today, but what we don't really have is just an easy way to say, hey, follow just semantic versioning and just kind of make it work, how it should. So you can see some examples here on the left. So if you have auto updates on, going from 1.1.1 to 1.1.2 to 1.1.3 just kind of works the way you would think. So those are just make it easier for teams that are building operators to just get things updated, and then for teams that are consuming them, admins just to get the updates as they would expect. And then if you did have, automatic updates on, it works. If you want to have a manual approval, this thing would wait for you to say, yes, I want to update to that version. So you've got both flows that you can unlock. All of this is without building an explicit graph, which is behavior that we had before where you could say this version replaces that version, and then, the next version out would replace that one, et cetera, et cetera. So that's exciting. That's going to be coming soon. We're laying some of the scaffolding for that today. On the SDK side, we've been integrating for several months now with an upstream project in Kubernetes called Kube Builder. This is a very low-level framework for building Go-based operators. It's kind of what a lot of the tooling inside of Kubernetes itself uses to build operators, or their controllers, what manages all of the life cycle of components. And so we're integrating with that. We don't want to have two competing projects for this. It just all makes sense to combine efforts. And so what we've been doing is modifying the way that our code scaffolding works to look very similar to these Kube Builder projects, and we're going to add a little wrapper in there so that you can adopt KubeBuilder projects, but then gain all of the stuff that our SDK adds around it. So if you think of KubeBuilder as it's literally just some code and some scaffolding, but you don't get the functional testing and all of the packaging, our CLI for doing all of the different workflows you need, a better user experience. That's what you'll get from using the SDK, even though the bits under the hood are some of that same KubeBuilder goodness. So this also aligns us with the upstream group, and we can all work together towards a common goal. So we're really excited about that. We're pretty close to this, and you'll see that coming for the first 1.0 of the Operator SDK. Next, I've talked about testing a few times. We're moving to embrace another open source project called Kuttl, Kuttl, for our scorecard test. So our scorecard is a way to both do validating and functional testing of an operator. And Kuttl has a really powerful way of doing assertion-based testing. So you install a version of the operator, and you change. Say you start 3 replicas, and it'll go make sure that you have 3 pods running or whatever needs to be running. Then if you change that to 4, did it actually change to 4, etc. So you can test out in a fairly light touch way your operator's behavior. And so we're going to integrate this into the SDK, and we hope this will make for a lot more mature operators, and so that folks can then even test these on their own. If you are at one of these big organizations and you do extensive validation of software before it gets in your environment, you can use these tests to validate it that it works exactly correctly in your environment as well. This is important as some operators, may call out to hosted services. Like a lot of monitoring tools will run an agent on your cluster, but then go talk to one of their SaaS services. And if you're in a disconnected environment, that might not work. So some of these testing tools can help you tease some of that stuff out. So we're pretty excited about that and working with that team as well. So just to sum it up, this is all the new stuff that we were talking about, the CSV list bundles. This is that new bundle format we were talking about. The SymVer-based upgrade logic, so not having to build this extensive graph. Being able to bundle functional tests with your operator. Building catalogs with Kubernetes tooling so that you can register a set of operators onto a cluster at the same time. More integrated packaging, so direct ties between the SDK and OLM, especially around that new bundle format, and then bringing KubeBuilder style operators into the framework. And then on the cluster admin side, some of more advanced dependency resolution and being able to disable that. The OPM tool for offline mirroring of all the containers needed for an operator, the new operator API, and then webhooks, and something we didn't talk about, which is the ability to choose a more fine-grained version of an operator instead of pulling off the latest one of a channel. You can choose. So that's all coming, and we're pretty excited about that. It kind of meets everybody's needs, from cluster admins to operator developers to operator users. And so that's basically all of the goodness we have coming in roughly the next year-ish. So you'll have to pay attention to the GitHub and mailing lists and all that to stay up to date on that. And we can always do another briefing, of course. And we'd love to have your interaction in those communities. So if you've got new features, you want to see us go in a different direction for something, or adopt a use case that you think maybe is not unique to you and that we should address for the entire community, we would love to have you on our different community calls, mailing lists, GitHub. Please interact with us. And so that's all I have. I think we're going to take some questions and just have some open discussion about the operator framework in general.
Yeah, well, thank you, Rob. And that was a pretty good tour de force, and there was a lot in that packed into that little half an hour. So one thing that would be really great, there's a couple of other folks that are on the call here. I know Austin's here. I'm just going to put you on view. There's the announcement should come shortly around the operator framework and incubation status for the CNCF. The vote went through the day before yesterday, I think. We finally got enough votes to move it over the line, and then a whole bunch more came in. So that's great. Huge shout out to the TOC for making this happen and working with us, and getting all of the, jumping through all the hoops was actually worth the effort, and we're really pleased to be there. So, and Austin is one of the organizers for the SDK working group, so the sub-working group of the operator framework. So just say hi, Austin. And if you wanted to get involved right now, where would you send people?
Yeah, the best place, the central hub for where to get in contact with us is the community repo in the operator framework GitHub. And that will point you to the other places, but just to give you a preview of what you might see, you'll see 3 working group meetings. The operator framework meeting, which is the 3rd Tuesday of the month. The operator SDK community meeting, which is monthly on the 1st Wednesday. And the operator framework OLM working group, which is every 2 weeks on Thursday. In addition to that, you can join the operator framework Google group or file issues on our GitHubs.
And I'm sure there'll be some more infrastructure and scaffolding created as we move over to the CNCF and all of the other SIGs and stuff like that. So watch for some transitioning news and information coming out in the upcoming days, and we'll probably have another chat about that sometime online as well. So there are a couple of questions, and I thought the first one was kind of pretty good. All those things that all the goodness you talked about in 4.5, Rob, are those coming in 4.5? And if they are they tech preview? And I would add, just to clarify, those are things that are in OpenShift. Are they also available for other Kubernetes?
Sure, yeah, I'll start with that one. So OLM works against any kube, and so a lot of the features that we talked about, the SDK runs on your laptop for the most part, and so anything cluster related is going to be OLM, and you can use that against any kube. So we do some testing on upstream, and of course it's built into OpenShift, and hopefully with the CNCF adoption, we'll see that get built into other kube distros as well. You get all of that kind of no matter where you're running, depending on which version of OLM you have. So in OpenShift for 4.5, the new operator API is going to be, it's not GA yet because it's going to be read-only. And so you can optionally enable a feature flag to use that new API, but it will only be reading. If you want to mutate those objects, you will use the old, interacting with a CSV directly or a subscription or install plan. And then if you, over successive releases, we'll have kind of the two-way binding on those objects and then eventually deprecate the old objects. But that'll happen over a long period of time as we start testing it out. So this is really a preview for folks just to check out that new API. We'd love feedback. We'd love any of that you have. So that, you can treat it more as a tech preview, not a GA yet.
Okay. I think maybe because we've been having so many conversations in different working groups about disconnected stuff, Waleed's got a question about not really a question, but if you could elaborate a little bit more on disconnected restricted environment enhancements and how people can overcome any possible constraints on how operators are built in the first place, assuming internet access. And he's also not quite sure what is that CSV.
Sure. So the CSV is a cluster service version, which is just the metadata around an operator. And so it's, the operator is a container. So where do I go get that container? How does it need to run? Does it need a special service account? When I do need a service account, what RBAC does that need to have? And so the CSV holds all that information, just about how to run and manage this thing. So that's what that is. Now for disconnected and restricted environments, what you need to do is for every mention of an operator's container or containers that it's going to spawn, so we call those the operands. So if you have a MySQL operator, then you would have operand pods of MySQL running on your cluster. So you need to basically tell that operator, hey, instead of going to get those from Quay or from Docker Hub or from this online registry, I actually need you to go get them from my private disconnected registry over here that's available, in my restricted environment. And so that's what all the features are about, is scaffolding the code of the operator such that swapping out those images, that's going to be the same digest, and so you're getting the same container, but it needs to come from a different place. And so that's where a lot of the scaffolding for disconnected is happening, is moving those container images around. Inside of the CSV, there's a special metadata field for related images, and this is all the operand images that this operator is going to stamp out. We need to know what those are, because you can embed them. If you're familiar with Helm charts, you'll see that, they're basically built as strings, and, sometimes you'll take in a tag. And so if we don't know the exact explicit image, we can't mirror them. We can't iterate every single tag that exists on this repo, and sometimes there's not even a way to find that out. And so there's a bunch of scaffolding to help you do that, and then that OPM tool will help you. So if you say, I want to mirror these 5 operators, that actually might translate to 40 or 50 different container images that actually need to make it into your environment. And so that tool helps you do that. So hopefully.
Waleed was pointing out that only a few of the operators support disconnected, according to some article he's read here in the chat.
Yeah, and so that represents that those folks need to embrace that little bit of indirection versus like explicitly calling out a specific operator image. Is they need to support folks mirroring it and then referencing that other image. Sometimes when you have hard-coded references, your hands are kind of tied there. That's what that article is most likely about, is a listing of which ones are hard-coded and which ones aren't.
I'm wondering if that's something, and this is just me thinking out loud, so apologies, if that's some piece of metadata that we could put on operatorhub.io to show whether something supported disconnected or not.
Exactly.
That might be.
Yeah, so that's something that we're looking to do for both Operator Hub and inside of OpenShift itself, is when you have that related images section filled out, we can reasonably assume that this operator has been tested in a disconnected environment. And so hopefully over time, as more operators are embracing this, is that we can then, maybe put that in our certification pipeline, is actually checking, that this does work in a disconnected environment, that kind of thing.
And Ryan was noting also that in a related update that from Minikube, which all of us know and loved, and wish there was a Minishift, that OLM is available as a plugin now. To Minikube.
Sweet, that's awesome.
That's pretty cool.
Yeah.
Let's see.
And so having OLM accessible to you as a developer, as an operator developer, is interesting, because that's how you can start testing all those upgrade paths yourself. Test that somebody can go from a single node of your application to a multi-node version of it, to maybe test out backup and restores, and that they can restore to a disaster recovery environment. All that stuff can be orchestrated locally as well. So that's important.
Yeah. So I'm not going to ask you the question I think that everybody wants to know is when is 4.5 actually coming out the door? And there's we all get shot for that, saying any dates and time, but it should be, all of what we're talking about here should be available in the not too distant future, and because it's all in timing. And then in 4.6, which is OpenShift 4.6, what are the key things that we can look to get in 4.6 of those, the next round of things? Yeah,
the main things for that are going to be getting that operator API into a read and write mode. And so we'll kind of have both of those living side by side in 4.6. And then some more extensive dependency management. And so this is something that we've been exploring as operators are starting to get more intertwined, as people are building products that, you have your application and you need a database, or you need, like a Kafka for that event stream like we were talking about. But you might want to depend not just on the latest version of a Kafka operator, but maybe a very specific version or a range of versions, or it's an optional dependency, not a required dependency. So bringing all of that type of fidelity to the dependency management is something that we're going to be exploring in 4.6 and beyond. It's not an overnight thing, but getting new features in 4.6 and some in 4.7 and some in 4.8, et cetera.
So, and we have a number of SDKs already. Are there any? We've talked about Python SDKs, other SDKs. Are there any other SDKs in the works at the moment? Is there anything that from Austin or others that we're looking at building out? Because we always talk about Helm and Ansible and Go and now the KubeBuilder stuff, and that. Why do we maybe? How do we get more languages and more approaches into this mix, or are there plans for that?
Austin, you want to take this one?
Sure. So the Helm and the Ansible operators are not, they're a language of themselves, but they are actually under the hood, they are Go operators as well. And so you can kind of think of them as more like a shim operator that allows operators in those respective languages. If you wanted something in Python or any other language, it's going to require the creation of controller runtime in that language. So we're not there yet. It's something that we're still considering, and it gets brought up every now and then, but we're not actively working on it yet.
It usually gets brought up by me, but that's usually something that comes in from the Python community.
Yeah.
So
that's what I was going to say. Is Python is probably one of the ones. And if you think about it, developers that are building against a stack know their stack. So if you run, if you're a big investment bank or something and you write Python, you probably want to build an operator in Python. Makes sense, you know. So that's where folks are kind of demanding that wide swath of stuff. And there's like a Java framework that's outside of our SDK that people use to build operators in Java and that kind of thing.
Yeah. So it looked like Joe,
Hey, Joe.
was waving his hand.
Yeah.
Something to add to that?
Can I add to that and say that if anyone is interested in helping contribute to develop some of those underlying libraries that are so critical to having, making it easy to develop the right primitives for operators, we're definitely interested in collaborating. So if you're out there and you've got a Python operator and you've written a lot of those primitives, definitely hit us up and let us know. I think probably one of the big hurdles is just having the expertise in those languages and knowing how to basically duplicate the equivalent of a scaffolding tool that can lay down files for a project in your language, and then also have the underlying libraries that make it really easy to basically give developers a reconciled method to implement. So I think the kind of the first thing that we're looking for is those kind of two building blocks. That's what's holding us back really at this point. So yeah, if anyone's interested in helping us do that, by all means, let us know.
Yeah, I think that part of what my hope is with the CNCF incubation project, that we'll get more visibility and get more resources and experts to help us build out some of the other pieces that will be helpful to continue to grow the adoption of operators and others. You mentioned, Rob, also the certified program for operators, and I wonder if you could talk a little bit about how people get involved in that or bring their wares to the operator certification that Red Hat has.
Sure. Yeah. So those are the two main flavors of operators. We have community listing at Operator Hub.io, and then we have vendors that are building commercially supported operators or building operators around their commercially supported software. And they want a way to kind of get like the stamp of approval from Red Hat that this software works well and integrates well with OpenShift. And so that's our certification program. And basically you can take your same code base and we run it through some testing, and we want to make sure that we can jointly support customers is a big part of this program. So it's not just technical, it's that we have agreements in place for how we can both support customer tickets and escalations and bugs and things like that in a reasonable time frame. So that's all about that wrapped up into that program. We have a web page. I don't have it off the top of my head, but if you search for Red Hat Operator Certification, you'll find it, and that's where you can go and get in touch with some of our engineers, and we can start looking at your operator, make sure that it works well, get it through our testing pipeline, and do some of the other business side of things to get that certification to happen. Then we've got like probably over 100 now, I think, certified. So it's a well-oiled machine, and across all the categories that we talked about. We've got storage vendors, we've got all the major databases, we've got a bunch of machine learning stuff and some monitoring services and all kinds of things. So we'd love to have your product listed there as well.
Yeah, and this is from the community side of things. If you go to operatorhub.io, there's a whole set of documentation in there to step you through, if you have an operator, how to get it in there. And there's also I think the interesting thing about the hubs, and that is that they're really kind of based on a catalog and what you could resurface and rebuild your own operator hub or whatever using the underpinnings as well. And that is out there in the open source land as well. So for those of you who are standing up your own operator hubs, there is a way, there's a an easy way for you to do that as well. So interesting to see that. I think there's about just under 140 community operators in operatorhub.io at the moment, and it's a pretty interesting group of folks who have come in, not quite randomly, but and a lot of them are done in conjunction with this. They do a certified operator, and they also put one in the community as well. So it's a pretty easy onboarding process in both ways. So we hope that if you are building an operator, that you will come and also offer something up in the operatorhub.io and make it available to that. Let's see. What is the advice for enterprise workloads? Should we stick to 4.3? I don't know. That sounds like it's beyond the scope of an operator conversation. That's a big conversation. 4.3.
We can touch on it really quick if you want. So just understand that in OpenShift, we have a new model where we're doing these over-the-air upgrades with OpenShift 4, and that's to keep you kind of up to date with Kubernetes as it's changing, as it's being updated for new features, bugs, security enhancements, etc. And so we encourage folks to upgrade as often as we release. So getting from 4.3 to 4.4 to 4.5 is really important for staying on top of the security of your cluster. And remember, that's the version of the operating system as well, is all being managed with that version. And the guarantee in all of our API versioning is that we will not break your workloads, and that's including over that upgrade. You should not experience downtime for your applications, and if you do, that's a bug, and we want to fix it. And so, we have these tools in place to do these over-the-air upgrades so that when you're managing a fleet of clusters, it's not any harder to manage one cluster as it is 100. And so hopefully, you don't have too many excuses to not go from version to version to version. You can also skip versions if you want and migrate your applications as well. But all of the workloads that we have, we're guaranteeing to not break that compatibility with the Kube API version, so the group version in kind. Looks like Waleed wants to be unmuted.
Yes, I've done that. So Waleed, speak up. You may have to unmute yourself.
Hi, I am asking this question because, for example, when you talk about vendor operators like Portworx, NSX from VMware, they are certified on a certain release, and most of them they certify on 4.3. And some of Red Hat consultants gives us this advice that they say, stay on the stable 4.3 latest GA, don't move to 4.4. And actually, that's what I'm trying to do today. I'm trying to downgrade to 4.3. But I'm wondering if this is like a good trusted advice, or as you say that we should move forward, but then I will be missing out on the quality insurance that the vendor testing does basically. I know, for example, VMware, they haven't tested 4.4 with their NSX operator, which should be going out. So what do you think, Rob?
So, always, like, if Portworx or VMware or whatever is a hard dependency on you, of course, listen to the guidance of where that's supported. But I know we're constantly talking to both of those vendors on getting them testing the latest versions as soon as possible and certifying those on their side as fast as possible. And so we want everybody to kind of move forward together. So that we stay up to date with all the work going on in Kube, the feature set going on in OpenShift, and then the features inside of their product as well, and keeping that all moving in quick succession. And so it's sometimes this is a new model for some of those vendors, and so we're working with them. So I would continue for you to work with them as well and try to get them into this kind of more cloud-like experience of consuming software versus set it and forget it kind of thing.
Just to point out, the more you ask for it, the more they'll listen.
Yeah. I also think that everybody recognizes the complexity of the ecosystem that we're in at the moment. The interdependencies of Kubernetes operators brings more to the table. OpenShift release cycles. This is a very complex world, and we are, we're all in conversations constantly with the partners, with the upstream folks, and trying, that's part, I'm not going to keep going back, that's part of the wonderful part about being included in the CNCF incubation process is hopefully we'll get more visibility of what the other pieces and parts of the universe of cloud native ecosystem looks like, and can have more conversations with these other folks. Not that, like with KubeBuilder and was it Cuddle? There are a lot of these conversations that have already been going on with Helm 3 and lots of other folks in the background. But I think that's just, this is one of the complexities of such a big ecosystem, is managing all those relationships. And the more we can do it out in the open, and the more we can do it transparently with lots of sunlight on it and lots of eyeballs on it, the easier it'll be. And I think Portworx and the other folks that you mentioned, Waleed, they're all in this community with us together, and we're all learning together. So it's getting alignment with release cycles, feature sets. The more we talk about it, the better off we all are. So yeah, touch base with your operator vendor partners, and I know those ones that you mentioned are definitely in conversations with us quite a bit. So hopefully we can get there. So I'm wondering if there's any questions. Let's see, there's a couple more chat things here coming in. Dan is asking, is there a roadmap for the Red Hat operators that will be released to the operator hub, i.e. will there be advanced cluster management? Well, that was yesterday's topic. No, but we'll let Rob answer that one.
I don't know if there's a specific roadmap. It's kind of up to each team. I know that the ACM, the Advanced Cluster Management team, does have an open source version, as is classic with Red Hat. I don't know if they've packaged that. Since you're asking the question, I'm going to go ahead and assume no. So I can't comment on what that team is going to do there, but we want that team to have ownership over the packaging and management of that operator, just like we want any of the other open source projects to do that. So I can't comment on their roadmap, but I hope they list it. I would love to see that.
Yeah, that would be great. And I know we've had an ACM talk yesterday. We'll have a few more talks, so you'll have opportunities to nudge them in that direction as well. So stay tuned and we'll let us know. Are there other operators that people who are on this call that are missing, or that you're looking for besides ACM? I think ACM is top of brain for everybody. Yes, there is one. Someone's asking. The ACM recording from yesterday has not been uploaded to YouTube, but if you look on the Twitch stream, the raw one is available on Twitch. Unfortunately for the ACM one yesterday, the demo went south. The demo gods were not with them. So we will be redoing that again, and there's another one next week. So Wally said the most important one to them is the Open Data Hub one. Is there one for Open Data Hub yet?
I thought maybe there's not, actually. I thought there was.
I don't think so yet.
Okay.
Yeah, I know we done anything commons wise with Open Data Hub, right? Like I looked earlier and I couldn't find anything. Diane, did you do one earlier this year?
Well, we've done lots of briefings. I don't think there could be an operator for Open Data Hub. Open Data Hub is a thing. Bird did a great demo of that, but I don't and actually this is a good segue. We're having an AMA in a couple of weeks on a Monday, if you look at the calendar, with the Open Data Hub team at noon Eastern, 9 a.m. Pacific, and I'll look up the calendar in a second, but you can ask them that. But Open Data Hub per se is not something that would be a single operator that you would, in my thinking of the way that we look at Operator Hub. Open Data Hub has lots of components to it, and it's more of a reference architecture than a single operator. But yeah, that's where we're at with that. So maybe Rob, if you could just take a moment and on your screen share, go to the GitHub repo so that we end this with where to go for everything, and so people see that as like the final thing going off, at where they can log an issue, find more information. Yeah. And there we go. So this is the GitHub repo.
Sorry, I muted.
That's okay. The GitHub repo and the Google groups are really, if you go to the community page under here, I think there should be /community. This is really where you can find out how to get a hold of us, to participate in this. And as I said at the very beginning, this too will change. There will be a little probably cleanup, migration over to, and we've done a lot of work getting ready for the CNCF donation and the being incubated by the CNCF. So not drastic changes, but you should see some other pieces and parts of this pop up in the coming weeks or so. So what I wanted to really do is just, Rob, do you have any final words that you want to add to here?
I'll just say that we're really excited about the CNCF news, and we're excited to get an even stronger community than we already have together through that organization. So we'd love to hear from you how you're building operators. Like I said, we want certified operators, we want community operators being listed. We just want to make this as big and as powerful as possible and meet everybody's needs. So please get involved. Slack, mailing lists, find us at conferences, whatever it is. We'd love to hear from you.
Yeah, that's the other thing. You know, we will be around, especially for the CNCF KubeCon that's coming up in shortly, a few weeks, months, whatever, soon. So, you know, look for us there. We should have a bit of a splash there with the announcement. And a lot of us will be online in the chats for the many operator related conversations and talks there. So you can definitely find us there, and we're looking for you and your participation in this community. So thanks again, everybody, for joining us today, and we'll be there for you, and hopefully you'll join us and in this adventure.
Yeah, thank you, everyone.
All right.